All right, so just like Windows, iOS, Mac OS, Linux is an operating system. In fact, it just so happens to work out that it's one of the most popular platforms on the planet. Even Android is powered by the Linux operating system. So an operating system is software that manages all of the hardware resources associated with your desktop or laptop. So to put that simply, the operating system manages the communication between your software and your hardware. So without the operating system, the OS, the software that you have wouldn't function. So Linux has zero cost of entry. Yeah, you heard that right. It's free. So that means you can install Linux on as many computers as you like without having to pay a cent for software or server licensing. Linux is also distributed under an open source license. So an open source will follow these key tenets: the freedom to run the program for any purpose, the freedom to study how the program works and change it to make it do what you wish, the freedom to redistribute copies so that you can help your neighbor, the freedom to distribute copies of your modified versions to others. So Linux has a number of different versions to suit any type of user. For new users to hardcore users, you'll find a flavor of Linux to match your needs. So these versions are called distributions, or in short, distros. In fact, nearly every distro of Linux can be downloaded for free, burned onto a disk or USB thumb drive, and installed on as many machines as you like. Some of the popular Linux distributions include Debian, Ubuntu, Linux Mint, Solus, Fedora, Elementary OS, OpenSUSE, Manjaro, and of course, Kali Linux. Now, don't think that the server has been left behind. For this arena, you can always turn to Red Hat Enterprise Linux, Ubuntu Server, CentOS, SUSE Enterprise Linux. Now, some of the above server distributions are free, such as Ubuntu Server and CentOS, and some have an associated price, such as Red Hat Enterprise Linux and SUSE Enterprise Linux. Those with an associated price, of course, will also include support. So the Linux operating system comprises several different pieces. Bootloader, the software that manages the boot process of your computer. For most users, it will simply be a splash screen that pops up and eventually goes away to boot into the operating system. Kernel, this is the one piece of the whole that is actually called Linux. The kernel is the core of the system, and it manages the CPU, memory, and peripheral devices. The kernel is the lowest level of the OS. Init system. So this is a subsystem that bootstraps the user space and is charged with controlling daemons. One of the most widely used init systems is systemd, which also happens to be one of the most controversial. It is the init system that manages the boot process once the initial booting is handed over from the bootloader. That is Grub or Grand or Unified Bootloader. Daemons. So these are background services, printing, sound, scheduling, etc., that either start up during boot or after you log into your desktop. Graphical server. So this is a subsystem that displays the graphics on your monitor. It's commonly referred to as the X server or just X. Desk environment. This is the piece that the users actually interact with. There are many desktop environments to choose from: GNOME, Cinnamon, Mate, Pantheon, Enlightenment, KDE, XFace, etc. Each desktop environment includes built-in applications, such as file managers, configuration tools, web browsers, and games. Applications. So desktop environments do not offer the full array of apps, right? Just like Windows and Mac OS, Linux offers thousands upon thousands of high-quality software titles that can easily be found and installed. Most modern Linux distributions, we'll talk about this more below, will include an App Store-like tool that will centralize and, simplify application installation. For example, Ubuntu Linux has the Ubuntu Software Center, which is a rebrand of GNOME software. But anyway, it'll allow you to quickly search among the thousands of apps and install them from one centralized location. Who doesn't like that? Now, a shell is a user interface for access to an operating system's services. So in other words, if the user wants the operating system to do something, they will then use a shell for this purpose. It's a command language interpreter that executes commands read from input devices such as keyboards or even from files. So in general, operating system shells use either a command line interface, CLI, or graphical user interface, GUI. Command line shells called terminal in Linux and Mac OS or command prompt in Windows. Graphical shells provide means for manipulating programs based on graphical user interface or GUI by allowing for operations such as opening and closing, moving, resizing windows, as well as switching focus between windows. Now, it's named a shell because it's the outermost layer around the operating system kernel. The kernel is a computer program that is the core of a computer's operating system, with complete control over everything in the system. So it'll manage the following resources of the Linux system: file management, process management, input-output management, memory management, device management, etc., etc. Now, there are several shells for Linux, such as TCSH, KSH, and ZSH. But one of the more common ones is Bash, where the name is an actual acronym for Born Again Shell. So each shell does the same job, but it understands different commands and provides different built-in functions. So if the screen shows a $sign or hash on the left of a blinking cursor, well, you're in a command line environment. The $sign and hash symbols indicate the user account type that you're logged into. The $sign means you are a normal user. Hash means that you are the system administrator or root. Now, in the C shell, the prompt ends with a percentage sign. The tilde means home directory. That is the default directory when first logging in. Now, there are differences on prompts in different Unix or GNU Linux distributions because of their default settings. But in general, the prompt usually shows the login username, machine host name, and current working directory, and ending with a $sign, percentage, or hash sign. So a desktop environment is the first thing you're going to see when your computer is ready for you to use. Windows and Mac users will usually find the concept confusing because both of these operating systems come pre-installed with their desktop environments, right? But with Linux, you can actually select and install any desktop environment that you want to place on your system. I'll show you some of the best desktop environments. GNOME. GNOME is easy to use. A clean and modern desktop environment that's a bit minimalistic, I would say, compared to other available Linux desktop environments. GNOME is well known, and it's one of the most useful and best Linux desktop environments for Linux users. XFace, or XFCE, is one of the most lightweight desktop environments out there. So if you have an old computer and you need to have more free memory for other applications, Xface is very suitable for this. KDE is one of the most popular desktop environments. You may also refer to it as the Plasma desktop. Plasma offers all the tools required for modern desktop computing experience, so you can be productive right from the start. Now, Unity, I would say, is probably one of the best-known versions of the Linux desktop. It was a former default interface for Ubuntu. From Ubuntu 17.10 to the GNOME desktop environment has become the default interface instead of Unity. So it looks modern and offers good filtering features. All right, so the Linux file hierarchy structure defines the directory structure and directory contents in Unix-like operating systems. It is maintained by the Linux Foundation. / represents a root folder. All files and directories appear under the root directory, even if they are stored on different physical or even virtual devices. Only the root user has the right to write under this directory. So /bin, essential command binaries that need to be available in user mode. For example, cat, ls, cp, etc. /home, the user's home directories containing saved files, personal settings, and all that kind of stuff. /sbin, Linux commands located under this directory are used typically by system administrators for system maintenance purposes like rebooting, ifconfig, that kind of thing. /boot contains bootloader files. For example, grub files are located under /boot. /etc, and you may have heard /etc. This will contain configuration files required by all programs. For example, resolve.config. /lib. These are libraries essential for the binaries in /bin and /sbin. /dev. Essential device files, including terminal devices, USBs, or any device attached to the system. For example, /dev/null. /opt. This will contain optional application software packages. /proc contains information about system process and kernel. /mnt, temporary mount directory, where sysadmins can mount file systems. /var. It contains variable data like system logging files and temporary files. /media mounts points for removable media such as CD-ROMs and the like. /tmp contains temporary files created by system as well as users. /srv contains site-specific data served by this particular system, such as data and scripts for web servers. /user contains binaries, libraries, documentation, and source code for second-level programs. So Kali Linux has around 600 pre-installed penetration testing programs, tools, including Armitage, which is a graphical cyber attack management tool, Nmap, which is a port scanner, Wireshark, a packet analyzer, Metasploit, which is a penetration testing framework, awarded as the best penetration testing software, in fact, John the Ripper, which is a password cracker, SQLmap, automatic SQL injection and database takeover tool, AirCrackNG, a software suite for penetration testing wireless LANs, Burp Suite, and OWASP Zap, web application security scanners, etc. So it was developed by Mattia Haroni and Devin Kearns of Offensive Security through the rewrite of Backtrack, their previous information security testing Linux distribution based on Knoppix. Originally, it was designed with a focus on kernel auditing, from which it got its name, Kernel Auditing Linux. Kali Linux is based on the Debian testing branch. Most packages Kali uses are imported from the Debian repositories. So the first version, 1.0.0 or Moto, this was released back in March of 2013. So with version 2019.4 in November 2019, the default user interface was switched from GNOME to XFCE, with GNOME version still available, but with version 2020.3 in August 2020, the default shell was switched from Bash to ZSH, with Bash remaining as an option.
Okay, so you may know all that, so in this video, we are going to explore Kali Linux. And by the way, it's always good to refresh your memory of all the little details in case you didn't know any of that history. Great. Now you know some. But in any event, we did learn that Kali Linux user interface was switched from going home to accessory, so that means that we're now going to explore the excessive user interface. So first off, XFCE is a lightweight desktop environment for Unix-like operating system, right? So it aims to be fast and light on system resources while still being visually appealing and easy to use. So the FCC desktop environment is not a single entity that provides all functionality, right? Rather, it tries to adhere to the old Unix tradition of small tools to do one job and really do it well. All right, so let's go ahead and take a closer look at the Kali Linux excessive user interface. Now, in a default session, there is a full with panel at the top of their screen. And the top panel shows a graphical pager with a miniature view of all the workspaces. You can switch a workspace easily task list showing all the applications running on the current workspace and a system tray to show status icons that are used, for example, by some media players or instant messaging applications. Over here on the top right corner, you can see the date clock, Ethernet network notifications, battery status. You can also lock the screen and manage your session. So over on the top left corner, you can list the applications. The applications are separated according to their titles. More you can list all the applications from here, it's okay too. At the bottom right corner of the application menu, here is where you can see the setting manager. So you manage your settings from this menu. And also up the top left corner here, you can minimize all open windows, create or open a specific folder. Over the terminal, use a command line. Now let me show you, if you right-click on the desktop, as you can see, you can create a launcher URL link folder document. Now, if you want to open a terminal or find a folder, well, easy to do that too. And here's a desktop setting. You can customize your background. Menu icons. VirtualBox is an open-source virtualization software that can be used with many operating systems. So VirtualBox is deceptively simple, but also very powerful. Let's get started. To install VirtualBox, open your favorite web browser. VirtualBox is typed in your favorite search engine. Find the virtualbox.org website. Click Downloads from the results. This page contains installation packages for different operating systems. These packages include Windows, macOS, Linux, Debian, Fedora, Ubuntu, OpenSUSE, Oracle Linux, and Solaris. For the Windows operating system, we download the Windows hosts installation file. Click the Save File button on the screen that appears and download the installation package to our computer. The file size is large. The download will take time depending on the speed of your internet connection. When the installation file is downloaded, there will be an exe file starting with VirtualBox in the folder you used for download. We can start the installation. Double-click on the VirtualBox exe file. Click the Next button on the incoming screen. This screen lists the applications that need to be installed with VirtualBox. Below is where VirtualBox will be installed. If desired, this location can be changed by clicking the Browse button on the side. We will use the default installation location. Program Files, Oracle VirtualBox for installation. Click the Next button. On this screen, there are shortcuts and file-saving buttons for VirtualBox. Click the Next button. Network interfaces set up for VirtualBox starts on this screen. Click the Yes button. Click the Install button on the incoming screen. The files required for installation are installed on the host computer. Click the Finish button on this screen to finish the installation. The installation is successfully completed. Now we can install virtual computers. Throughout the course, we will use the Kali Linux operating system, which is widely used in penetration testing. And Kali Linux is an open-source Linux distribution based on Debian. It comes installed in many hacking programs used in penetration tests. Therefore, it is widely used. We can install Kali Linux distribution on our host computer in several different ways. One of these methods is installation with ISO file. Opens your favorite web browser. From your favorite web browser, type Kali Linux in the search engine. The official website of Kali Linux is at the top of the results. Click here to download it. This screen lists the different ISO installation images available for Kali Linux. Each of these is released in 32-bit and 64-bit. Kali Linux uses the GNOME desktop by default. Click on Kali Linux 64-bit at the top. Click the Save button to download the ISO image file to your computer. The file size is large, and the download will take some time depending on the speed of your internet connection. When the file download is complete, go to the folder saved by your web browser. As you can see, the download has completed successfully. You can follow the steps below to install Kali Linux operating system with ISO file. Open Oracle VirtualBox application. Click the New button on the main screen. On this screen, we will install a virtual Kali Linux machine. Name information, type the name we will use for the virtual machine. Information on where to install the virtual machine. By default, the VirtualBox application sets virtual computers to CE users username VirtualBox VMS folder. We can change this location by clicking the down arrow. I create all virtual computers under a single folder to make it easier. My recommendation would be to put all virtual computers under a single folder. I use a folder called VMS on my computer. I create all my virtual computers here. I find the VMs folder by clicking the down arrow. I create a folder named Kali here. I click the Select Folder button. In the ISO image section, we write the path of the ISO file we downloaded earlier, or click the down arrow button to find the file on our computer. That's how it works. If you want, you can show the ISO file for later installation. When we use the ISO file, the type and version information is automatically filled in below. If we had not selected the ISO file, we would have to set these fields ourselves. In this case, we select Linux and type in Ubuntu, 64-bit in version. Click Next. We click the Next button. This screen determines the amount of RAM and CPU we will give to our virtual machine. VirtualBox shows minimum and maximum values according to the RAM and CPU values of the host machine you are using. These values can be changed after installation. So we set 2048 MB as RAM and 2 as CPU. Click the Next button. On this screen, we specify the disk system of the virtual machine. If we want to create a new virtual disk, click Create a Virtual Hard Disk. If we want to use a disk we've already created, click Use an existing virtual hard disk. We're going to create a new disk, so we click on the top option. We select 20 GB as the size. Click Next. On this screen, we will see the specific information about the virtual computer we are going to create. Click on the Finish button. When the creation process is complete, we can see the name of the virtual computer we created on the left side of the VirtualBox main screen. On the right side, we can see the properties of the virtual machine we created. We can change these properties by clicking the Settings button. Return to the main screen and click the Start button. Our virtual machine is turned on, and we see the Kali Linux installation screen. On this screen, select Graphical Install with the arrow keys and press Enter. Select the language to be used. Click the Continue button. Select the location. Click the Continue button. Select keyboard type. Click Continue. Enter the virtual computer name. Click Continue. If we are using domain name, enter the domain name. Click the Continue button. Username, Kali. Click the Continue button. Enter the root password to be used on this screen. We will use Tor password as password. Click Continue button. Select the time zone that the virtual machine will use. Click Continue button. The disk system is detected by the installation. Click Continue on the incoming screen. Click Continue on the incoming screen. Click Continue on the incoming screen. On this screen, Kali has made the necessary changes to the virtual disk system as the operating system. Click Continue. Click Yes to confirm the changes. Click Continue. The operating systems and programs are now installed. This process will take time depending on the resources you have provided to the virtual computer. Click the Continue button. Click Yes for Grub Bootloader to be used at startup. Click the Continue button. Choose where to install the Grub loader. To do this, click on a half-day FDA. Click Continue. Click the Continue button. The installation is complete. The virtual computer boots up and the username and password screen appears. Username, Kali, and password, PASSW0RD. We can install the Kali Linux distribution with the ISO, or we can install it with the already installed virtual machine imager. These imagers are designed to be used by various VMware and Oracle VirtualBox virtualization programs, both 32-bit and 64-bit. Open your favorite web browser. Type Kali Linux in the search engine. Enter the download page. Click on Virtual Machines option. On this page, there are virtual computer image files ready for VMware and VirtualBox. Click on Kali Linux VirtualBox images. Click to download the Kali Linux VirtualBox 64-bit OVA image file to our computer. This process will take time depending on your internet speed. Add Kali Images VirtualBox. Click on the image file we downloaded earlier. Image file is downloaded with 7's extension. Extract the compressed file by right-clicking on it. You can use the extracted file either in the folder where it is located or by copying it into another folder. My recommendation would be to collect all virtual computers under a single folder. I use a folder called VMS on my computer, and I create all my virtual computers here. You can right-click on the image file and copy or move it with one of the copy or move options. Now, let's add our virtual computer to the VirtualBox menu. Open the VirtualBox program. Click the Add button. Click on Kali Linux VirtualBox images. Click on the image file. You will see that the virtual computer has been added to the VirtualBox menu. Start the virtual computer by clicking Start. Click the Add button. In the window that opens, navigate to the folder with the image file. Click on the file with the EveryBox extension. You can see that the Kali Linux virtual machine has been added. We can start the virtual computer with Start. The opening screen comes up. The username and password information is written in the description section of the virtual computer. Enter username, Kali, and password, Kali, and the virtual computer is ready to be used. Description: Metasploitable is a virtual machine image created by SourceForge. This virtual machine has many vulnerabilities. Metasploitable is an intentionally vulnerable Linux virtual machine. This virtual machine can be used for security training, testing security tools, and practicing common penetration testing techniques. To install Metasploitable, you first need to download the disk image file to your computer. For this, open your favorite web browser. Type Metasploitable in the search engine. Click on the link belonging to SourceForge among the results. Click on the Download option on this screen. When the Save button is clicked on the screen, the image file starts to be downloaded to the computer. The download process will take time depending on the internet connection speed. Add Metasploitable VirtualBox. Open the VirtualBox program. Click the Import button. On the screen that appears, navigate to the folder where the OVA file is located. You can do this by clicking the folder icon next to the box labeled File. Select the file. Click Open. Click Next to proceed to the next step. This section contains general information about the virtual computer. At the bottom of the window, in the Machine-Based Folder section, we determine where the image file will be installed. My recommendation would be to collect all virtual computers under a single folder. I use a folder called VMS on my computer, and I create all my virtual computers here. You can right-click on the image file and copy or move it with one of the Copy or Move options. I go to the folder, click Open Folder. Click Finish and wait for the import process to finish. At the end of the import process, you can see that Metasploitable has been added to the VirtualBox menu. Start the computer by clicking Start. Enter username and password. The default credentials are username, Vagrant, password, Vagrant. You may get an error message like this after adding Metasploitable. This is due to a problem with the virtual machine's Ethernet cards. To solve this problem, click Setting of the Metasploitable virtual machine. Click Network on the left side. Click Adapter 2 on the right side screen. Remove the box next to Enable Network Adapter. Click OK and exit. Start Metasploitable. And the virtual computer is ready to be used. Description: Wscube Broken is a virtual machine image created by SourceForge. This virtual machine has many vulnerabilities. Wscube Broken is an intentionally vulnerable Linux virtual machine. This virtual machine can be used to provide security training, test security tools, and practice common penetration testing techniques. To install Wscube Broken, you must first download the disk image file to the computer. For this, open your favorite web browser, type Wscube Broken in the search engine, click on the link belonging to SourceForge among the results. Click on the Download option on the screen. When the Save button is clicked on the screen, the image file starts to be downloaded to the computer. The download process will take time depending on the internet connection speed. Add Metasploitable VirtualBox. On this screen, we will install Wscube Broken machine. Right-click on the OWASP image file and open the compressed file. Image file is ready to use after extract. You can use the extract file either in the folder where it is located or by copying into another folder. My recommendation would be to collect all virtual computers under a single folder. I use a folder called VMS on my computer, and I create all my virtual computers here. I select all the extracted files and copy them by right-clicking. Then I go to the VMS folder. Here, I create a folder called OWASP and paste the files into this folder. We open the VirtualBox program, click the New button, name information. Type the name we will use for the virtual machine. Where to install the virtual machine. By default, VirtualBox installs virtual computers in C user's username VirtualBox VMs folder. If you want, we can change this location by clicking on the down arrow. I find the VMS folder by clicking the down arrow. Here I click on a folder called OWASP. I click the Select Folder button. Select Linux and type and other 64-bit inversion. Click Next. We click the Next button. This screen determines the amount of RAM and CPU we will give to our virtual machine. VirtualBox shows minimum and maximum values according to the RAM and CPU values of the host machine you are using. These values can be changed after installation. So we set 1024 MB as RAM and 2 as CPU. Click the Next button. On this screen, we specify the disk system of the virtual machine. I need to introduce the disk image I extracted to the VirtualBox program here. For this, we click Use an existing virtual hard disk. In the window that opens, click the Add button. In the window that opens, we find the OWASP image file. We click on the OWASP Broken Web Apps clone.vidk file. Click the Chose button. Click Next button. On this screen, we can see specific information about the virtual computer we will create. Click the Finish button. When the creation process is complete, we can see the name of the virtual computer we created on the left side of the VirtualBox main screen. On the right side, we can see the properties of the virtual machine we created. We can change these properties by clicking the Settings button. Return to the main screen and click the Start button. Open the virtual machine and enter username and password on the login screen. Username, root password, OWASP. Our virtual machine is ready to use. We will set up a virtual network structure for the applications we will do in the training. In this way, we will prevent damage to real systems and other devices connected to the network while making applications. It is necessary to set up a virtual network in the VirtualBox because during the course, we will ensure that all the virtual machines we will use are in the same virtual network. A network is the ability of multiple devices to communicate with each other wired or wirelessly. It is used for connection to a network device. Usually, we will configure a NAT network so that all virtual machines are on the same network. When we create a NAT network, the virtualization program will automatically assign IP to all computers on this network. IP is the address required for a computer to communicate with other computers over the network. Each computer must have a different IP. Every computer connected to the internet has an IP address. IP stands for Address for Computers. Each computer must have a different address. There are two different versions of the IP address, IPv4 and IPv6. The commonly used IPv4 is 32 bits long. It consists of four 8-bit numbers, each separated by dots. Example, 192.168. 1.1. Each group of numbers can have a value between 0 to 255. If there are two computers with the same IP, there will be IP conflicts on the network. DHCP Dynamic Host Configuration Protocol is used to prevent this. DHCP assigns a different IP to each computer. This does not cause IP conflict. To set up a NAT network, click on File, click Preferences, click Network on the incoming screen. Click Adds New NAT Networks on this screen. Click on the arrow sign, Exit is done. To add virtual machines to the NAT network, click on the virtual machine, click on Setting, click Network on the incoming screen. On this screen, select NAT network from Attached to Option. Click on the arrow sign. Repeat the same process for other virtual computers. Connection test, testing that the installed virtual machines can communicate with each other. For this test, we need to check that each virtual computer can communicate with each other. For this, it is enough to check whether the virtual computers are on the same network and ping each other. To check the IP value, the network settings can be checked, or it can be checked from the command line. It is more preferable to use the command line because many programs used for penetration testing run on the command line. Command line command is an important advantage. Not all programs have guy screens. To check the IP value from the command line, this process is done in different ways for Windows and Linux, macOS operating systems. For IP control in Linux and macOS operating systems, terminal opens, type ifconfig at the command line and press Enter. In the screen that appears init 10.0, 2.7 is the computer IP. The IP value here may be different for your system. IP check for Windows computers. Open the command line. Click on Start. Search in CMD is type. Click on CMD.exe. Open the command line. Type ipconfig at the command line and press Enter. The screen will display IPv4 address, 10.0.2.6 computer IP. The IP value here may be different on your system. Now we need to test that Kali Linux virtual system can communicate with other virtual systems over the network. For this, open Kali Linux, click on Terminal. The IP address of the Metasploitable computer. To do this, type ping Metasploit IP value and press Enter. The screen will show that the ping packets are going. This means that communication is taking place. Putting the IP address of the OWASP computer. To do this, enter ping OWASP value and press Enter. The display shows that ping packets are going out. In this case, communication is taking place. Ping the IP address of the Windows 7 computer. For this, ping Win7 IP value and press Enter key. The screen shows that the ping packets are going. In this case, communication is taking place. If it is seen on the screen that ping packets do not go, this may be because ping requests are blocked on the firewall on the Windows 7 computer. In this case, you can test whether there is communication by doing the reverse operation. Log in to the Windows 7 computer. Click the Start button, type CMD in the search field. Open the command line. Enter the IP address of the Kali Linux computer in the command line. Type ping Kali IP value and press Enter key. It is seen on the screen that ping packets are going. In this case, communication is taking place. Ping the IP address of Windows 8 computer. For this, ping Win8 IP value is typed and Enter key is pressed. The ping packets are shown on the screen. In this case, communication is taking place. If it is seen on the screen that ping packets do not go, this may be because ping requests are blocked on the firewall on the Windows 8 computer. In this case, you can test whether there is communication by doing the reverse operation. Log in to the Windows 8 computer. Click the Start button. Type CMD in the search field. Open the command line. Enter the IP address of the Kali Linux computer in the command line. Type ping Kali IP value and press Enter key. It is seen on the screen that ping packets are going. In this case, communication is taking place. The IP address of the Windows XP computer. For this, type ping Windows XP IP value and press Enter key. The ping packets are shown on the screen. In this case, communication is taking place. If it is seen on the screen that ping packets do not go, this may be because ping requests are blocked on the firewall on the Windows XP computer. In this case, you can test whether there is communication by doing the reverse operation. Log in to the Windows XP computer. Click the Start button, type CMD in the search field, open the command line. Enter the IP address of the Kali Linux computer in the command line. Type ping Kali IP value and press Enter key. It is seen on the screen that ping packets are going. In this case, communication is taking place. Now our NAT network is ready. Download and install VMware. VMware is a licensed virtualization software that can be used with many operating systems. To install VMware Workstation Player, open your favorite web browser. VMware is typed in your favorite search engine. Find the VMware website. Find Try Workstation Player on the VMware webpage and click Download. On the screen that appears, click Save File and download the installation package to our computer. The file size is large. The download will take time depending on the speed of your internet connection. When the installation file is downloaded, there will be an .exe file starting with VMware in the folder you used for download. We can start the installation. Navigate to the folder where the VMware installation file is located. Double-click on the VMware file. Click the Next button on the screen that appears. On this screen comes the VMware license screen. Check the box and click Next. This screen shows where VirtualBox will be installed. If desired, this location can be changed by clicking the Change button on the side. We will use the default installation location for installation. There are additional features related to VMware below. You can click on them if you want it. Click the Next button. Click Next without making any changes on this screen. You can remove the boxes if you want. This screen contains shortcuts for VMware. Click the Next button. Click the Install button on the incoming screen. The files required for installation are uploaded to the host computer. Click the Finish button on this screen to finish the installation. The installation is successfully completed. Now we can install virtual computers. Throughout the course, we will use the Kali Linux operating system, which is widely used in penetration testing. Kali Linux is an open-source Linux distribution based on Debian. It comes installed in many hacking programs used in penetration tests. Therefore, it is widely used. We can install Kali Linux distribution on our host computer in several different ways. One of these methods is installation with ISO file. Opens your favorite web browser. From your favorite web browser, type Kali Linux in the search engine. The official website of Kali Linux is at the top of the results. Click here to download it. This screen lists the different ISO installation images available for Kali Linux. Each of these is released in 32-bit and 64-bit. Kali Linux uses the GNOME desktop by default. Click on Kali Linux 64-bit at the top. Click the Save button to download the ISO image file to your computer. The file size is large, and the download will take some time depending on the speed of your internet connection. When the file download is complete, go to the folder saved by your web browser. As you can see, the download has completed successfully. Kali Linux ISO installation. You can follow the steps below to install Kali Linux operating system with ISO file. Open the VMware Player application. Click Create New Virtual Machine on the main screen. On this screen, we can use a disk we created before at the top. You can continue the installation by selecting the Installer Disk Image Files file, or you can use the operating system at the bottom later. We will continue by selecting the ISO file. On this screen, the operating system type and version to be installed are selected. Select Ubuntu 64-bit as version. Click the Next button. Name information. Type the name we will use for the virtual machine. Where to install the virtual machine? By default, the VMware Player application sets virtual computers to see user's username documents virtual machines folder. We can change this location by clicking Browse. I create all virtual computers under one folder for simplicity. My recommendation would be to put all virtual machines under one folder. I use a folder called VMs on my computer. I create all my virtual computers here. I find the VMS folder by clicking the down arrow. I create a folder named Kali here. I click the Select Folder button. In the ISO image section, we write the path of the ISO file we downloaded earlier, or click the down arrow button to find the file on our computer. That's how it works. Click Next. We click on the Next button. On this screen, we specify the disk system of the virtual machine. We select 20 GB as the size. Click Split Virtual Disk into multiple files. Click Next. On this screen, we display specific information about the virtual computer we will create. Click the Finish button. When the creation process is complete, we can see the name of the virtual computer we created on the left side of the VMware main screen. On the right side, we can see the properties of the virtual machine we created. We can change these properties by clicking the Settings button. Return to the main screen and click the Start button. Our virtual machine is turned on, and we see the Kali Linux installation screen. On this screen, select Graphical Install with the arrow keys and press Enter. Select the language to be used. Click the Continue button. Select the location. Click the Continue button. Select keyboard type. Click Continue. Enter the virtual computer name. Click Continue. If we are using domain name, enter the domain name. Click the Continue button. Enter the root password to be used on this screen. We will use Tor password as password. Click Continue button. Select the time zone that the virtual machine will use. Click Continue button. The disk system is detected by the installation. Click Continue on the incoming screen. 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 On this screen, Kali has made the necessary changes to the virtual disk system as the operating system. Click Continue. Click Yes to confirm the changes. Click Continue. The operating systems and programs are now installed. This process will take time depending on the resources you have provided to the virtual computer. Click Yes on the screen that appears. Click Continue. Click Yes for Grub bootloader to be used at startup. Click the Continue button. Choose where to install the Grub loader. To do this, click on a half-day FDA. Click Continue. The installation is complete. The virtual computer boots up and the username and password screen appears. Username, Kali, and password, PASSW0RD. And the virtual computer is ready to be used. We can install the Kali Linux distribution with the ISO, or we can install it with the already installed virtual machine imager. These imagers are designed to be used by various VMware and Oracle VirtualBox virtualization programs, both 32-bit and 64-bit. Open your favorite web browser. Type Kali Linux in the search engine. Enter the download page. Click on Virtual Machines option. On this page, there are virtual computer image files ready for VMware and VirtualBox. Click on Kali Linuxware images. This process will take time depending on your internet speed. Add Kali Images VMware Player program. Click on the image file we downloaded earlier. Image file is downloaded with 7's extension. Extract the compressed file by right-clicking on it. You can use the extracted file either in the folder where it is located or by copying it into another folder. My recommendation would be to collect all virtual computers under a single folder. I use a folder called VMS on my computer, and I create all my virtual computers here. You can right-click on the image file and copy or move it with one of the copy or move options. Now let's add our virtual computer to the VMware Player menu. Open the VMware Player program. Click on the image file. You will see that the virtual computer has been added to the VMware Player menu. Start the virtual computer by clicking Start. The opening screen comes up. The username and password information is written in the description section of the virtual computer. Enter username, Kali, and password, Kali. When a virtual computer is ready to be used, description. Metasploitable is a virtual machine image created by SourceForge. This virtual machine has many vulnerabilities. Metasploitable is an intentionally vulnerable Linux virtual machine. This virtual machine can be used for security training, testing security tools, and practicing common penetration testing techniques. To install Metasploitable, you first need to download the disk image file to your computer. For this, open your favorite web browser. Type Metasploitable in the search engine. Click on the link belonging to SourceForge among the results. Click on the Download option on this screen. When the Save button is clicked on the screen, the image file starts to be downloaded to the computer. The download process will take time depending on the internet connection speed. Add Metasploitable to VM Player. Open the VMware Player program. Click Open Virtual Machine. In the window that opens, find the Metasploitable image file you downloaded. Select the image file. Select the file. Click Open. In the window that opens, enter the virtual machine name and specify the folder where you will install the virtual computer. Select the folder by clicking the Browse button. I create all virtual computers under a single folder to make it easier. My recommendation would be to put all virtual computers under a single folder. I use a folder called VMs on my computer. I create all my virtual computers here. Click the down arrow to find the VMS folder where I create a folder called Metasploitable. Click the Import button. If the warning window appears, click Retry. The import process may take some time. When the import process is finished, Metasploitable computer will be added on the left side of the VM Player main screen. Start the computer by clicking the Play button. Enter the username and password. The default credentials are username, Vagrant, password, Vagrant. Our Metasploitable virtual computer is ready to use. Description. Wscube Broken is a virtual machine image created by SourceForge. This virtual machine has many vulnerabilities. Wscube Broken is an intentionally vulnerable Linux virtual machine. This virtual machine can be used to provide security training, test security tools, and practice common penetration testing techniques. To install Wscube Broken, you must first download the disk image file to the computer. For this, open your favorite web browser, type Wscube Broken in the search engine, click on the link belonging to SourceForge among the results. Click on the Download option on the screen. When the Save button is clicked on the screen, the image file starts to be downloaded to the computer. The download process will take time depending on the internet connection speed. On this screen, we will install Wscube Broken Machine. Right-click on the OWASP image file and open the compressed file. Image file is ready to use after extract. You can use the extract file either in the folder where it is located or by copying into another folder. My recommendation would be to collect all virtual computers under a single folder. I use a folder called VMS on my computer, and I create all my virtual computers here. I select all the extracted files and copy them by right-clicking. Then I go to the VMS folder. Here, I create a folder called OWASP and paste the files into this folder. Open the VMware program. Click Open Virtual Machine. In the window that opens, find the OWASP image file you downloaded. Select the image file. Select the file. Click Open. When the import process is finished, the OWASP virtual computer will be added on the left side of the VM Player main screen. Start the computer by clicking the Play button. Enter username and password. Username, root, password, OWASPWA, our Wscube Broken virtual machine is ready to use. We will set up a virtual network structure for the applications we will do in the training. In this way, we will prevent damage to real systems and other devices connected to the network while making applications. It is necessary to set up a virtual network in the VMware program because during the course, we will ensure that all the virtual machines we will use are in the same virtual network. A network is the ability of multiple devices to communicate with each other wired or wirelessly. It is used for connection to a network device. Usually, we will configure a NAT network so that all virtual machines are on the same network. When we create a NAT network, the virtualization program will automatically assign IP to all computers on this network. IP is the address required for a computer to communicate with other computers over the network. Each computer must have a different IP. Every computer connected to the internet has an IP address. IP stands for address for computers. Each computer must have a different address. There are two different versions of the IP address, IPv4 and IPv6. The commonly used IPv4 is 32 bits long. It consists of four 8-bit numbers, each separated by dots. Example, 192.168. 1.1. Each group of numbers can have a value between 0 to 255. If there are two computers with the same IP, there will be IP conflicts on the network. DHCP, the Dynamic Host Configuration Protocol, is used to prevent this. DHCP assigns a different IP to each computer. This does not cause IP conflict. VMware NAT network created. To set up a NAT network, when a virtual computer is installed on VMware Workstation Player, it is created in NAT network by default. To see that the virtual computer you set up is in the NAT network, open the VMware Workstation Player program. Click on the virtual computer. Click Edit Virtual Machine Setting on the right side of the screen. The virtual machine settings screen will appear. You can see that NAT is written in the Network Adapter section. Do the same for other virtual computers and complete your checks. Connection test. Testing that the installed virtual machines can communicate with each other. For this test, we need to check that each virtual computer can communicate with each other. For this, it is enough to check whether the virtual computers are on the same network and ping each other. Now let's test that the Kali Linux virtual system can communicate with other virtual systems over the network. For this, open Kali Linux, click on Terminal, typing the IP address of the Metasploitable computer. To do this, type ping Metasploit IP value and press Enter. The screen will show that the ping packets are going. This means that communication is taking place. The IP address of the OWASP computer. To do this, enter ping OWASP IP value and press Enter. The display shows that ping packets are going out. In this case, communication is taking place. The IP address of the Windows 7 computer. For this, enter ping Win7 IP value and press Enter key. The screen shows that the ping packets are going. In this case, communication is taking place. If it is seen on the screen that ping packets do not go, this may be because ping requests are blocked on the firewall on the Windows 7 computer. In this case, you can test whether there is communication by doing the reverse operation. Log in to the Windows 7 computer. Click the Start button. Type CMD in the search field. Open the command line. Enter the IP address of the Kali Linux computer in the command line. Type ping Kali IP value and press Enter key. It is seen on the screen that ping packets are going. In this case, communication is taking place. Ping the IP address of Windows 8 computer. For this ping Win8 IP value is typed and Enter key is pressed. The ping packets are shown on the screen. In this case, communication is taking place. If it is seen on the screen that ping packets do not go, this may be because ping requests are blocked on the firewall on the Windows 8 computer. In this case, you can test whether there is communication by doing the reverse operation. Log in to the Windows 8 computer. Click the Start button. Type CMD in the search field. Open the command line. Enter the IP address of the Kali Linux computer in the command line. Type ping Kali IP value and press Enter key. It is seen on the screen that ping packets are going. In this case, communication is taking place. Connection test. The IP address of the Windows XP computer. For this, type ping Windows XP IP value and press Enter key. The ping packets are shown on the screen. In this case, communication is taking place. If it is seen on the screen that ping packets do not go, this may be because ping requests are blocked on the firewall on the Windows XP computer. In this case, you can test whether there is communication by doing the reverse operation. Log in to the Windows XP computer. Click the Start button, type CMD in the search field, open the command line. Enter the IP address of the Kali Linux computer in the command line. Type ping Kali IP value and press Enter key. It is seen on the screen that ping packets are going. In this case, communication is taking place. Now our NAT network is ready.
All right, so in this lecture, we're going to look at the components of Linux commands. So these are the examples of Linux commands. ls and ifconfig are command names. We're going to practice them with the next lecture, and you'll see how they work. But for now, let's examine the structure of the command components. /bin is an argument of the ls command. An argument, also called command line argument, can be defined as an input given to a command line to process that input with the help of a given command. So arguments are entered in the terminal or console after entering the command. They can be set as a path, so we could also write more than one argument together, and they will be processed in the order that they are written. Now, a parameter is an argument that provides information to either the command or one of its options. They are optional, and you're also free to use whatever parameter suits your particular needs. Single character parameters are used with a single dash. More than one parameter can be used behind a dash, so ls-al can be used instead of ls-a-l. Now with double dash parameters, more than one character can be used, such as here, ls double dash help. So in this case, a new double dash must be used for each parameter. Make sense? So as a result, the first command lists the files and directories under the /bin folder with long format by showing permissions. All right. The second command displays the detailed information about the ifconfig command. The ls command is used to list files or directories in Linux and other Unix-based operating systems. Just like you navigate in your File Explorer or Finder with a GUI, the ls command allows you to list all the files or directories in the current directory by default and further interact with them via the command line. -a or double dash all parameters lists files or directories, including hidden files or directories. So in Linux, anything that begins with a dot, that is considered a hidden file. -l lists the contents of the directory in a table format with content permissions, size of the content in bytes, and last modified date and time of the content. -h or double dash human readable display size information with human readable format. -s or double dash size, where s is lowercase, lists files or directories with their sizes. -uppercase s lists files or directories and sorts by date or time in descending order, or from biggest to smallest. Finally, -t is the parameter that lists files or directories and sorts by last modified date and time in descending order, from biggest to smallest. So let's go ahead and practice. So go to Kali, Log in with the default credentials, Kali and Kali. Open up the command line. Now you can change the font size from the preferences under the File tab. Click on Change. I'm going to set the size to be 14. Okay, so that's better for me. Now let's run the ls command with the help parameter, and we'll be able to see some detailed information. So you can see the arguments, options, and parameters here, and you can use them when needed. They're all right here. So I'll show you some of the most common options. Now, and by the way, you can clear the screen with Control L. So let's list all the files under the /user/bin folder with -al parameter. And as you can see, we find all the files, including the hidden files, with the long listing format. And these are the permissions and last modified date of the file. So let's look at the file sizes with the human readable format. And as you can see, the file sizes are more readable now. Now the next parameter is lowercase s, and it'll show you the total size and sizes of each file. And then finally, we'll use the t parameter, and it sorts the files and directories by the last modified date and time from biggest to smallest. All right, so in this lecture, we will see the pwd command. PWD stands for Print Working Directory. And as the name suggests, it prints the current directory. So let's go to Kali. Run pwd. Now, as you may remember, the tilde sign means the home directory, and you see that we are in the home directory of the Kali user. So why don't we change the directory to /user/share/nmap/scripts and list files. So now let's run the pwd command again. And as you can see, we now see the full path of the current directory. The man command. Man is the abbreviation of manual, so it gives detailed information about the named command, including name, synopsis, configuration, description, options, exit status, return value, as well as errors. Now, the manual is divided into multiple sections, so we can pass a section number as an argument to get a specific section of the manual for a given command. And this table shows the available sections. Section 1 is default. It opens the user command descriptions if no section is given. Now, if you run man password, it shows the manual of the password command. And if you specify the section number, for example, 5, it'll show the format of the file. All right, so let's go to Kali. Run man pwd to see the manual page of the pwd command. And there it opens section 1 by default. So just press Q to quit. So what if we run the man command? And of course, it shows us the manual page of the man command. Say that 3 times fast. That's all right. You don't have to. Great. So obviously there's lots of detailed information about the man command, right? You can read through this at another time, but know that it's here. So this time we'll specify a section number. 1 is the default section, and it shows the user commands. So let's try to see section 5 of the password command. And as you can see, it shows the file formats and conversions of the password command. Now the cd command, or change directory command, this is used to change the current working directory in Linux and other Unix-like operating systems. It's one of the most basic and frequently used commands when you're working on the Linux terminal. You can specify the path of the directory, and in addition to that, you can change the directory with some special symbols. A double dot is a symbol for the upper folder. A single dot is the symbol for the current folder. So if you run cd double dot, it moves you to the previous folder. If you run cd command without any parameter, it'll give you the home folder of the current user. cd tilde user moves to the home directory of the named user. And finally, cd single dash moves to the previous position. All right, so let's go ahead and practice it. So go to Kali, change directory to /user/share/nmap/scripts. And now let's check the current folder with the pwd command. Okay. So now let's move to the previous folder with a double dot. Cool, now check the current folder again. And as you can see, we have now moved to the upper folder. So let's go ahead and run the cd command without parameters and check the current folder. And you can see that we are in the home folder of the Kali user. Now, if we run the cd command with dash, we'll move to the previous position. And yeah, so let's see how we just moved back to the Nmap folder. So let's go to the home folder again. This time use the tilde sign. Okay, great. Well, now we're back at the home folder again. The cat command is one of the most frequently used commands in Linux, Unix-like operating systems. The cat command allows us to create single or multiple files, view the contents of a file, concatenate files, as well as redirect output in terminal or files. That's where the cat command comes from, right? Concatenate. I didn't just trip over that word. Anyway, generally it's used to see the content of a text file. I'll just show you how it works, all right? So follow along. First, list files, and there are 2 different text files here. So let's check out the content of the my text file with the cat command. And these lines are written inside the text file. So if we want to add a new word or statement to this file, we can use a double greater than symbol. I'll just write the new line and quit with Control and C. So let's see the content of the file again. And as you can see, we've added one more line to the text file. So what if we only use one greater than symbol? So let's add in a new line again, run the cat command. single greater than symbol overwrites the entire content with the new line we just added. That's powerful stuff. So let's see the content of the mytext file 2 this time. So if we run the cat command with both mytext file and mytext file 2, we'll see the contents of both. Now the echo command is one of the most basic, as well as frequently used commands in Linux. So it displays a line of text and the arguments passed to echo are printed to the standard output. So let's practice it. Go to Kali, run echo path, and it displays a line of text on standard output. Now if you want to display the variables, you'll need to add a $sign to the variable. So let's run echo $path. This time it shows the path environment variable that keeps track of certain directories in Linux. So hopefully you remember cat shows the content of the file, and there is a single line in the mytext file. We can also add a new line to this file with the echo command. So run echo a new line double greater than mytext file. Let's see the content. And there it is. It's been added. All right, so we showed in the cat command the single greater than symbol overwrites the entire content with the new line. Just remember that. And here we have the more command. It's used to view the text files in the command prompt, displaying one screen at a time in case the file is large, for example, log files. So if you press enter or space, it'll move to the next page. The line number specifies a line where you want to start displaying the text content. And you can press Q to quit. Let's go to Kali. All right, so we can open the syslog file because it's large enough to open with the more command. And it's under the /var/log folder. Oh, and we get permission denied. Okay, so it's an error. But as you remember, some commands, operations, or files require root privileges. And as a standard user, we won't be able to access these files, or we won't be able to, perform any of these important actions. So to change the user to root, just run sudo more /var/log/syslog, enter the password. Okay, so let's press enter or space to go to the next page. We can also see how much of a percent of the file that we've already read. And press Q to exit. So let's add a line number. If we add a number with a dash, it'll display the 12 lines in a page. So let's add a number with a plus sign, and it specifies a line where you want to start displaying the text content. So it started displaying from line 123. Now, the less command is a command line utility that displays the contents of a file or command output, one page at a time. So you see how it's similar to more, but it actually has more advanced features. So you can search for a word in a file, move to a specific line, and it allows you to go both backward and forward within the line. So let's play around with that.
run sudo less /var/log/syslog. You can now press the arrow keys to go back and forward. So let's search for a database, for instance, right? /database. And yeah, there you go. It finds it easily. So now let's go to a specific line. I'll move to the 86th line, for instance. Okay, well, we cannot see the line number, but I believe that we are in the 86th line. All right, so just quit out of that. So the head command is a command line utility for outputting the first part of the files given to it via standard input. Right? So it writes the results to standard input, but by default, head returns the first 10 lines of each file that it is given. You can add a number with the -n parameter to see the first specified lines if you want. You want to see how that works? I want to show it to you. So change directory to the /user/share/nmap/scripts. List files. And as you can see, there are lots of Nmap script files. So let's run one of them with the head command. And it displays 10 lines by default. So let's specify a number with the -n parameter. Okay, so this time we see the first 20 lines of this file. Here's the tail command, and it complements the head command, as you might imagine. So it'll display data from the end of the file. It'll write results to standard output, and by default, tail returns the last 10 lines of each file that it is given. It may also be used to follow a file in real time and watch as new lines are written to it. So to watch a file for changes with the tail command, just pass the -f option. This will show the last 10 lines of a file and will update when new lines are added. Hey, what about going to Cali? All right, so here we are under the /user/share/nmap/scripts folder. And let's just run any file with a tail command to see the end of the file. Okay, so if we specify the number, for example, 40, we see the last 40 lines of the file. Now let's follow a file in real time with -f parameter and see how it repeats every 2 seconds. It's very handy to watch log files that change regularly. And let's quit out of that by pressing Control and C. Now grep, this is a command, well, I'll tell you that grep stands for globally search for a regular expression and then print it out. So that's why we say grep. But the grep command basically searches a file for a particular pattern of characters, and then it'll display all the lines that contain that pattern. The text search pattern is called a regular expression. So when it finds a match, it prints the line with a result. The grep command is handy when searching through very large log files, for instance. The -i parameter is used to perform case-insensitive searches. You can use regular expressions with -e parameters. -r parameters can be used to read all files under each directory recursively. And then finally, the -v parameter. We use that when we want to select non-matching lines. All right, so let's give it a shot. Let's go to Cali. Let's read the content of the /etc password file. So this is a plaintext file that contains a list of the system's accounts, giving for each account some useful information like user ID, group ID, home directory, shell, and so much more. Of course, we could search for a particular pattern in this file. So let's run grep cali /etc/passwd. And here, as you can see, it filtered the result containing Kali. So why don't we use a regular expression with the -e parameter? So Linux regular expressions are special characters which help search data and matching complex patterns. So if we add the caret symbol to the beginning of a word, it'll display the patterns that start with Kali. Now, to do a case-insensitive search, we can always add the -i parameter, and we'll capitalize the first letter of Kali so that we can see the result. Now, as you can see, the result did not change. It shows the patterns that start with Kali regardless of upper or lower case. All right, so now let's perform a recursive search. So we can search for OpenVPN under the /user folder recursively. We can also see the full path of the matched pattern. Now, if you want to select non-matching lines, you can just use the -v parameter, and it shows the patterns that do not start with Kali. So the command uname displays the information about the system. -a is the option that prints out all the system information. So I'm going to give it a shot, see what it looks like. Run uname, and it displays the operating system name. Let's add the -a parameter to print all available information. And of course, respectfully, as well as respectively, the output includes the kernel name, host name, kernel release date, kernel version, machine hardware name, and operating system name. Pretty cool, huh? Puts you in the driver's seat. So redirection is a feature in Linux so that when executing a command, you can change the standard input-output devices. The standard input device, of course, is a keyboard, and the standard output device is the screen. But check this out. A single greater than symbol is used to overwrite the output file with the result set. The double greater than symbol is used to append the result set to the target file. The single less than symbol is used to add the results as an input for another command. As you may remember, we practiced output redirection while running the cat and echo commands. I wonder if you noticed. Well, let's try it here and see if you recognize it. So first run echo hello world single greater than my text file. Now look at the content of the file. We overwrite the file. So this time let's use a double greater than symbol. And this time we add a new line to the text file. So let's use input redirection. So in the previous lectures, we looked at the etc or etc/password file, and that contains a list of the system's accounts. There were some values on a line separated by a colon, run cut-d:-f1 less than etc/password. So in the first command, we got the first values of each row with the -f1 parameter. We needed a delimiter to separate them, and we used the colon for this with the -d parameter. So we gave the etc/password file as the input to the first command by using input redirection. So, do you remember what this file looked like before? And as you can see, we extracted the first column of each line. So a pipe is a form of redirection, and it sends the output of one command to another command for further processing. So pipe is used to combine two or more commands. And in this, the output of one command acts as the input of another command. And this command's output may act as an input to the next command. It can continue, believe me. Now, pipes, it's important to note, are unidirectional, right? In other words, data flows from left to right through the pipeline. All right, so now you know all that. Let's try it out. Now, in Kali, there is an important file that stores the actual password in encrypted format for the user's account, with additional properties related to the user password. The name of this file is Shadow. It's under the /etc folder. So why don't we dig in and have a look at the content of this file? Oh, and of course it requires root privileges, so just add sudo to the beginning of the command. Okay, so these are the encrypted form of the user's passwords. Let's read the first 3 lines of this file with the head command. So we'll combine the 2 commands with the pipe redirection. So the output of the one command acts as an input to another command. Yeah. Okay, so now change the directory to the /user/bin folder. Run ls-l pipe grep my. And the grep command takes the output of $ls-l as its input. The net effect of this command is that the output of the ls-l is displayed one screen at a time. So the pipe acts as a container which takes the output of ls-l and gives it to the grep as input. So the mkdir, the mkdir, is a command in Linux that allows users to create or make new directories. Mkdir stands for make directory. So with mkdir, you can also set permissions. You can also create multiple directories or folders at once, and really so much more. You can also build a structure with multiple subdirectories using mkdir with the -p option. So why don't we just get into it and get practicing? So go to Kali, and if you want to list files in a directory that doesn't exist, you're going to get this error message. So why don't we create the directory with mkdir? Change directory to the temp folder. Now, if you want to create multiple subdirectories, you can always use the -p option. And we'll check the subdirectories using the cd command. All right, no problem. They were loaded under the temp folder. The touch command is a standard program for Unix and Linux operating systems that's used to update the access and modification times of the file or files to the current time. So a file argument that does not exist is created empty. All right, so why don't we try it out? Go to Kali, list all the files that start with my,
And there are two text files, and these are their modification times. So let's change the modification time of my text file 2. We need to create a new file with the same name as this file with the touch command. And let's check the time again. And sure enough, its modification time was updated. So now let's create a new document. And you see how an empty text file was generated under the current directory. RM. It stands for remove. So the RM command is used to remove objects such as files, directories, symbolic links, and so on and so forth from the file system of Linux. The -R parameter is used to remove directories and their contents recursively. -D parameter is used to remove empty directories. -F parameter is used to ignore non-existent files and arguments. This command normally works silently, and you should be very careful, actually, when you're running RM commands, because once you delete the files, then you are not able to recover the contents of these files and directories, all right? But with that being said, let's see how it works. So list all the files that start with temp. As you can see, I've got two directories. The second one, temp1, is the folder that's empty. So first I'm going to try to remove the temp folder. Now when I try to remove non-empty directories without parameters, I'll get an error. That's a good thing. So if I use -D parameter for a non-empty folder, I'll get an error again. So I need to remove this non-empty folder with the -RF parameter that forces and removes directories, like I said, recursively. So let's list directories. Okay, the temp folder is no longer available. So we'll use the -D parameter to remove an empty folder named temp1. And we'll list the directories again. What? There's no directory that starts with temp? Good job. All right. The CP command. This is going to copy files and directories or copy multiple sources to a destination directory. The -R parameter is used to copy directories recursively. The MV command will move or rename files or directories, or it can move multiple sources and their files and directories to a destination directory. -F parameter is used to not prompt before overwriting. So why don't we go to Kali and you'll see what I mean. We're going to practice. We'll first list the files. So we'll copy the mytext file to the temp folder. And as you remember, dot represents a current directory. Temp folder is under the current directory. And list files in the temp folder. All right, so here it is. So now go to the temp folder. We can rename this file with the MV command. List files again. And as you can see, we changed the name of the file. So we can move this file to another folder with the MV command as well. Let's move it to the home folder of the Kali user. Run the cd command without any parameter, and that'll take us to the home folder. List the files again. Okay, so these are the copied and moved files. They were actually the same files from the very beginning. So what do we have here? Let me look for, oh, right, it's the find command. Ha. Anyway, the find command is one of the most important and certainly frequently used command line utilities in Unix-like operating systems. It's used to search and find a list of files and directories according to the conditions that you specify for files matching arguments. It has a wide range of uses. For example, you can always search by names, permissions, search depth, logical comparisons, and the list goes on. But instead of listing, let's try it out. So after typing the find command and the location that you want to search in, you need to add -iname. So this is a parameter to find files using their name and ignoring the case. So I'll search for all files that end with NSE under the root folder. Okay, so here we go. This is a great example because, as you can see, I get some errors because of permissions. Now, to find all files, I'll need to run this command with sudo. Okay, so now it's found all the files that end with NSE. This time I'll use a somewhat complicated command, or it's more complex anyway. Let's search some files under the root folder and use the max depth parameter. So the max depth parameter is used to specify levels of directories below the starting points. For instance, number 1 means that you're going to find the file under the root folder and one level down. So the command I wrote in parentheses finds folders that do not have 700 permissions. Make sense? Then finally, the remainder of the command lists these folders. Okay, enter. Of course, you need to run this command with sudo because you are searching under the root folder. And as a result of the search, this file with the permission of 600 was found under the root folder. Of course, there are many utilities available in Linux and Unix systems that allow you to process and filter text files. Cut is a command line utility that allows you to cut parts of lines from specified files or piped data and print the result to standard output. So it can be used to cut parts of a line by delimiter, byte position, and character. -F is the parameter used to select only specified fields. With a -D parameter, a delimiter is used to cut data. So let's see how it works. Go to Kali. And the most common file to understand the usage of the cut command, I think, is /etc/password. So let's view the contents of this file again. As you can see, each data is separated by a colon. So that means that we can use the colon as a delimiter. Let's get the first fields of each line with the -F1 parameter. Okay, so this error is caused by the slash because password is a file, not a directory. So don't use the slash at the end of the file. Now let's delete it and run the command again. Okay, see how that works. We get the first fields of each row. So let's change the field numbers. You can select multiple fields just using a comma. And sure enough, we'll get the third and fourth fields of each row in the file. The first numbers are user IDs. The second numbers are the group IDs of the users. The chown command, or you may have heard chown. Either way you choose to say it, they're probably both acceptable. But anyway, the chown command changes user ownership of a file, right? Change ownership of a file, directory, or link in Linux. So every file is associated with an owning user or group. It's critical to configure file and folder permissions properly. Now, to change both the owner and the group of a file, use the chown command, followed by the new owner and group separated by a colon with no intervening spaces and the target file. So let's just practice it. First, list files with the -L parameters, see the permissions. And here you can see the owner and group of the mytext file are Kali. So let's change it. Run chown nobody :games mytext file. Oh, right. See, this operation needs root privileges. Of course, I knew that. I'm just showing you. Yeah. Then let's run this command with sudo. List the files again. And sure enough, I set the owner as nobody and the group as games. Now, I want to talk about service and services. A service is a program that runs in the background outside the interactive control of system users as they lack an interface. So this is in order to provide even more security because some of these services are crucial for the operation of the operating system. Right? All these services work on several scripts, and these scripts are stored in /etc/init.d. Okay, so this init.d is a daemon, which is the first process of the Linux system. To manage Linux services, you can use service and systemctl commands. You can learn the current status of services using the status all parameter. Service and systemctl commands are used to start, check the status of, and stop services. If the service is correctly configured, it'll start. Now, in Linux, there are several services that can be started and stopped manually in the system. Some of those services are SSH, HTTP, Tor, Apache, these kinds of things. So let's just try out what we've learned so far, and let's start the Apache service, right? So first, list all the services under the /etc/init.d location. Now, these are all the services. Let's check the status of them. Run service, status all. Okay, so plus signs mean that the service is active. The minus sign means it's not active. If you do want to check the status of a specific service, for example, Apache service, use the systemctl status command. So as you can see, Apache 2 service is inactive. You can also use the service command to see the status of the service. So let's start the Apache service, run service Apache 2 start. This operation needs root privileges, so enter the password. And let's check the status again. All right, so you see it's running now. So Apache is the world's most popular cross-platform HTTP web browser to deploy and run web applications or websites. We can display the default page of the Apache server on the web browser. So just enter the IP address of the machine. And yes, this is the default page of the Apache server. It'll show us that the Apache service is running. Now, a user is an entity in a Linux operating system that can manipulate files and perform several other operations. Each user is assigned an ID that is unique for each user in the operating system. Single user, single task. Well, just as the name implies, this operating system is designed to manage the computer so that one user can effectively do one thing at a time. The Palm OS, if you remember that, for Palm handheld computers, is a great example of a modern single-user, single-task operating system. Single-user multitasking. So this is the type of operating system most people use on their desktops and laptop computers today. Microsoft Windows and Apple's Mac OS platforms are both examples of operating systems that will let a single user have several programs in operation at the same time. Kind of take that for granted these days. But I'll give you an example. It's entirely possible for a Windows user to be writing a note in a word processor while downloading a file from the internet, while printing the text of an email message. Multi-user multitask operating systems allows many different users to take advantage of the computer's resources simultaneously. So it means that the operating system must make sure that the requirements of the various users are balanced and that each of the programs they're using has sufficient and separate resources so that a problem with one user won't affect the entire community of users. Unix, VMS, and mainframe operating systems such as MVS, these are some examples of multi-user operating systems. RTOS, RTOS, or real-time operating systems, well, these are used to control machinery, scientific instruments, as well as industrial systems. An RTOS typically has very little user interface capability and certainly no end-user utilities, since the system will be pretty much a sealed box when it's delivered for use. A very important part of an RTOS system is managing the resources of the computer so that a particular operation executes in precisely the same amount of time every time it occurs. All right, so the Linux file hierarchy structure defines the directory structure and directory contents in Unix-like operating systems. It is maintained by the Linux Foundation. / represents a root folder. All files and directories appear under the root directory, even if they are stored on different physical or even virtual devices. Only the root user has the right to write under this directory. So /bin, essential command binaries that need to be available in user mode. For example, cat, ls, cp, etc. /home, the user's home directories containing saved files, personal settings, and all that kind of stuff. /sbin, Linux commands located under this directory are used typically by system administrators for system maintenance purposes like rebooting, ifconfig, that kind of thing. /boot contains bootloader files. For example, grub files are located under /boot. /etc, and you may have heard /etc. This will contain configuration files required by all programs. For example, resolve.config. /lib. These are libraries essential for the binaries in /bin and /sbin. /dev. Essential device files, including terminal devices, USBs, or any device attached to the system. For example, /dev/null. /opt. This will contain optional application software packages. /proc contains information about system process and kernel. /MNT, temporary mount directory, where sysadmins can mount file systems. /var. It contains variable data like system logging files and temporary files. /media mounts points for removable media such as CD-ROMs and the like. /TMP contains temporary files created by system as well as users. /SRV contains site-specific data served by this particular system, such as data and scripts for web servers. /user contains binaries, libraries, documentation, and source code for second-level programs. Now, one thing a new Linux user will get to know as they progress in using it is the existence of several Linux distros and the different ways that they manage packages. So here, our main focus is going to be on some of the best package managers, in my humble opinion. DPKG is the Debian Package Management System. So DPKG is a base package management system for the Debian Linux family. So it's used to install, remove, store, and provide information about .deb packages. It's a low-level tool, and there are front-end tools that help users to obtain packages from remote repositories and or handle complex package relations, and these will include APT, or Advanced Packaging Tool, Aptitude Package Manager, and Synaptic Package Manager. The other package manager is RPM, or Red Hat Package Manager. This is the Linux standard base packing format and a base package management system created by Red Hat. Now, being the underlying system, there are several front-end package management tools that you will be able to use with it. Yum, or Yellow Dog Updater Modified, and DNF, or Dandified Yum. Pacman Package Manager, Arch Linux, is also a popular and powerful yet simple package manager for Arch Linux and some little known to Linux distributions. Zipper Package Manager, OpenSUSE. So this is a command line package manager on OpenSUSE Linux. Its common functionalities include repository access, package installation, resolution of dependencies issues, and so much more. Portage Package Manager, Gentoo. Of course, you can say Portage. Go for it. Anyway, this is the package manager for Gentoo. It's less popular Linux distro as of now, but that don't mean it's limited. It is one of the best package managers in Linux. So you've heard me mention it before, and you might not be clear, but I want to tell you that a software repository, or repo for short, is a storage location from which software packages may be retrieved and then installed on a computer. So package management systems look for the repositories for the packages. Now, since they all have package management systems, Linux distros use repos. So in Debian-based distros such as Kali and Ubuntu, repos are in the /etc/apt/source.list. And then we can use the apt-get command, and that's used to install and update packages. So to install a package, you do need to type the package name after typing apt-get install. And if you don't know the package name, you can search for available packages from the repositories using the apt-cache search utility. You can just run the apt search command. So to update packages and upgrade the installed systems, apt-get update and apt-get upgrade commands are very useful. Now, if you want to uninstall a package, then just run apt-get remove and the package name. Now, if you want to use a GUI to manage apt-get, you can always use Synaptic. Let's see how it works. So first, read the content of /etc/apt/source.list, and we'll see the repos. So these are the sources from which the packages will be installed from. Let's start with the update and upgrade. Yeah, sometimes you have to wait a little bit. Might take some time. Oh, but you know what? I did. I'm reading your mind now. I forgot to add sudo for the second command. All right, so now it's completed. All right, so now let's say that you want to install a program called PidCat, but you don't remember its package name exactly. Well, just search with a keyword. All right, so we found a package that was called PidCat, and we can just run sudo apt-get install PidCat. Press enter. And as if it was doing what it was told, it gets installed. So why don't we check its manual with the man command? All right, no problem. Press Q to quit. So let's say that you want to uninstall this package. Just run apt-get remove PidCat. Let's check it out. What happened to the PidCat package? Excellent. So if you do want to manage apt-get processes with a user interface, like I said before, you can install Synaptic. So why don't we install it with apt-get install? Okay, so that completes the installation. Let's run Synaptic. I'll skip the introductions. So on the left-hand side, there are different package categories. You can review this list here to find the best package, the one that you're looking for anyway. I want to look at the editors though. Okay, so I want to install LeafPad. So I'll right-click on this and select for installation. But wait, what is that? Forgot to run it with root. And here I am trying to get you to remember to run with root. No, I'm just playing. That's why I do this, because you're going to get it and never forget it. All right, so that's why for me it's not downloading. So I'll just quit Synaptic, run it with sudo. This time I use a search field to find LeafPad. Right-click on this and mark for installation. And sure enough, finally, I can click on the Apply button. So what do you know? This list shows the packages to be installed and unchanged packages. So I'll click on Apply, and now it's installed. Okay, so that's complete. I'll just close it. And just to make sure, I'm going to run LeafPad on the terminal screen. And yeah, it's an alternative way to install a package. So let's talk about a variety of tools for managing Debian packages, from graphical or text-based interfaces to low-level tools for installing packages. So all available tools will depend on lower-level tools to function properly and are presented here in a way that reduces the complexity, or perceived complexity anyway. So it really is important to understand that higher-level package management tools, such as Aptitude or Synaptic, rely on apt or apt, which in turn relies on dpackage or dpkg to manage packages on the system. All right, so dpackage is a software at the base of the package management system in the free operating system Debian and its numerous derivatives. Dpackage is used to install, remove, provide information about deb packages. Let's have a look, see how it works. Open up your terminal and write dpkg-help. And you can see the commands and definitions of them. All right, so what we're going to do is, well, just very simply install Skype. So you can see I've already downloaded the Skype.deb package from the official website, which I'm sure you know how to do. But now I'm going to show you how to install it. So here you see the .deb package. So go to this path from the terminal, right? You could also right-click and click Open Terminal from here as well. Now write dpkg-i and the name of the .deb file. Whoa! You do need to remember to be root to install a deb packet, so just write sudo at the head of the command. All right, now hit enter. And as you can see, boom, the download is completed. Let's have a look. And yeah, so here, Skype downloaded completely without an error. So let's talk about a variety of tools for managing Debian packages, from graphical or text-based interfaces to low-level tools for installing packages. So all available tools will depend on lower-level tools to function properly and are presented here in a way that reduces the complexity, or perceived complexity anyway. So it really is important to understand that higher-level package management tools, such as Aptitude or Synaptic, rely on apt or apt, which in turn relies on dpackage or dpkg to manage packages on the system. All right, so dpackage is a software at the base of the package management system in the free operating system Debian and its numerous derivatives. Dpackage is used to install, remove, provide information about deb packages. Let's have a look, see how it works. Open up your terminal and write dpkg-help. And you can see the commands and definitions of them. All right, so what we're going to do is, well, just very simply install Skype. So you can see I've already downloaded the Skype.deb package from the official website, which I'm sure you know how to do. But now I'm going to show you how to install it. So here you see the .deb package. So go to this path from the terminal, right? You could also right-click and click Open Terminal from here as well. Now write dpkg-i and the name of the .deb file. Whoa! You do need to remember to be root to install a deb packet, so just write sudo at the head of the command. All right, now hit enter.
And as you can see, boom, the download is completed. Let's have a look. And yeah, so here, Skype downloaded completely without an error. System monitoring can help users check on how much system resources are being used and which apps are consuming what percentage of it. It's very helpful. It helps the user to properly manage the applications as well as make sure that the system is in good health. Of course, there are many built-in tools available for system monitoring in Linux. So we'll look at some of them. So to see the status of disk, DF, which is an abbreviation for disk-free, this is the command used to display the amount of available disk space for file systems on which the invoking user has appropriate read access. The -H parameter prints sizes in human readable format, of course. Now, hopefully you remember from the previous lectures we already practiced the top command. So top command is used to show the Linux processes. It provides a dynamic real-time view of the running system. Now, to see the status of RAM, the /proc/meminfo file is another alternative way. It's used to report the amount of free and unused memory on the system, as well as the shared memory and buffers used by the kernel. To check the status of the CPU, Virtual Memory Statistics Reporter, also known as VMstat. This is a Linux command line tool that reports various bits of system information. So /proc/CPUinfo is a short read-only plaintext file that contains information about the CPUs, or central processing units, on a particular computer. Now, to check the status of the network, netstat can be used to list out all of the network socket connections on a system. There are some important parameters to netstat. -T is the parameter used to get TCP packets. -N is used to avoid domain name resolution. -L is the parameter used to list only the listening ports. The -P parameter is used to list the PID and name of the program. The -S parameter will get you some statistics. And of course, a root parameter displays the kernel routing table. That must be so confusing to the UK users, huh? Who say root and router. Anyway, let's go to Kali and look how each tool works. So first, let's run df-h. So as you can see, it displays the space available on all the currently mounted file systems. Now, if you happen to be using macOS, you can also run this in the terminal screen. So let's go back to Kali, run the top command. And these are the running processes with their PIDs, usage percentage of CPU, memory, some other detailed information. And press Q to quit. Now let's have a look at the content of the /proc/meminfo file. So this will display the status of the RAM, and the output of this command would be different depending on the OS and architecture of the server. All right, so let's continue with the status of CPU. VMstat
provides a number of values and will typically be called using two numerical parameters. Number 2 will provide the values and will be remeasured and reported every 2 seconds. Number 5 will provide the values that will be reported 5 times, and then the program will stop. All right, so no anticipating for you. Now, the other way to get some information about the CPU is the proc CPU info file. As you can see, there's lots of detailed information about CPUs, such as model name, cache size, speed, CPU cores, and all that. All right, so we'll have a look at the status of the network. Run netstat-tnlp. That'll show the active connections with TCP packets and PIDs. So let's use netstat-s parameter. As you can see, the -s argument will show overall stats, and this is how you can pay attention to packets discarded messages. And then finally, we can use the route parameter. Or is it root parameter? Well, not if I'm a root user. So if the connection's not working as expected because the connection goes through a different route, it may be necessary to quickly check the routing table. So it includes information about how packets are to be forwarded, and it's stored in a kernel structure. Ifconfig, or interface configuration. It's a command that's used to configure the kernel resident network interfaces. So it's used at boot time to set up the interfaces as necessary. So after that, it's usually used when needed during debugging or when you need system tuning, perhaps. If no arguments are given, ifconfig displays the status of the currently active interfaces. Also, this command is used to assign the IP address and net mask to an interface or to enable or disable a given interface. So let's just see how it works. So first, just run the ifconfig command without an argument. All right, so here it displays all the active interfaces details. This is the assigned IP address of the Kali machine. ETH0 is the name of the network interface. Now, to assign an IP address and net mask to a specific interface, just use the following command with an interface name, ETH0 IP address that you want to set, and net mask argument. So a net mask is a 32-bit binary mask, and it's used to divide an IP address into subnets and specify network's available hosts. So this operation also needs root privileges. I'm sure you know how to do that by now. Let's run the command with sudo. So let's check the IP address of the ETH0 interface. All right, so here is the newly assigned IP address. Now we're going to talk about a firewall and packet filtering. Okay, so a firewall is basically a filtering gateway, and it only acts on packets that need to pass through. So it can only be effective when going through the firewall is the only path for those packets. You follow? So the absence of a standard configuration explains a lack of a turnkey solution. However, there are tools that make configuring the NetFilter firewall way easier. So the NetFilter firewall is built into the Linux kernel. Due to different network and user requirements, there's no turnkey solution with any firewall ever, anywhere, even though they might market one. Anyway, you can control NetFilter from the user space using the IP tables and the IP6 tables commands.
Now, the difference between these two commands is that the first works for IPv4 networks, the second works on, guess what, IPv6. So you can also use UFW as a net filter firewall. That's, of course, what the cool kids call uncomplicated firewall. So UFW is a program for managing a net filter firewall designed to be easy to use. It uses a command line interface consisting of a small number of simple commands and uses IP tables for configuration. We're also going to see a very simple example. So in other words, however you decide to configure it, NetFilter is Linux firewall implementation. So why don't we just have a closer look, see how it works. So NetFilter uses 4 distinct tables, right? And these store rules regulating 3 kinds of operations on packets: NAT, filter, mangle, and raw. Now, each table contains a list of rules called chains. The firewall uses standard strings to process packets according to predefined conditions. All right, so the schema that you see on the screen is a schema of the NetFilter chain. Each chain is a list of rules. So each rule is a set of conditions and then actions that are going to be performed when the conditions are met. So let's use the IP table command. Open Kali. Let's start with the IP tables and we'll create some rules. Write sudo su dash for root permission. Write IP tables -h to see the commands. So you can see the parameters and the definitions of them. Now to see if it's working, let's create a simple rule. So first, write IP tables -l to list all the rules. And as you can see, well, we don't have a rule right now. So in this example, what we'll do is we'll accept all traffic from the SSH connection. So we'll write IP tables -a input -p TCP -dport 22-j accept. So the -a means append, and it adds the rule to the end of the current chain, or the chain that you specify. So in this case, input is the chain that we are adding the rule. -p specifies a protocol that we want to allow. We want to allow TCP connections because SSH uses TCP connections. ~dport is the destination port of the connection. So SSH uses port 22. And -j is what you want to have happen. So it's a target of the rule, and we want to accept SSH traffic. So hit enter and list the rules again. Write IP tables -l to list rules. And as you can see, we have successfully added the rule into the rule table. Now it's going to accept all traffic coming from port 22. Now let's say that you want to delete a rule. Well, first write IP tables -l ~line-numbers. And that way we can see which line that you want to delete. Here is our rule, and this is the one that we want to delete. So write IP tables -d and the chain name, which is input, and the number of the line, which is 1. Hit enter. List the rules again. And as you can see, the rule was deleted. Cool. All right, so now the next tool is UFW. Open the terminal and write UFW-help. And you can see the options here. So enable the firewall to allow or deny the connections or whatever. So what we're going to do is allow the SSH connection. Write sudo UFW allow SSH. And you can see here that the SSH rule was added. And then to activate the firewall, write sudo UFW enable, and the firewall is activated. Let's have a look at the active rules. So we'll write sudo UFW status numbered, and there you can see the SSH rule is activated. Awesome.
So Wireshark is not a disaster movie set in the wide open sea. It is a free, open source, and the world's foremost network packet analyzer. And it is the de facto standard across system and network administrators. With a graphical user interface, Wireshark has the ability to listen and record traffic, as well as advanced filtering and reviewing options. So I'm going to visit a HTTP website first, then an HTTPS website. Let's go to Kali and run Wireshark. You can open a terminal screen and type Wireshark to start it. So these are the network interfaces that Wireshark is able to listen to. Let me open another terminal screen and run the ifconfig command to see the network interfaces. So as you know, ifconfig stands for network interface configuration. So if we use the command without any parameter, it'll list all the interfaces available. We have eth0 as a network interface to listen to. So now I'll turn back to Wireshark and double-click eth0 to select it. Now Wireshark starts to listen to the Ethernet interface of Kali. And to create some traffic, I'll open a web browser and just visit an arbitrary website. And now we have enough packets to examine, so I'll click the Stop button at the upper left corner of Wireshark to stop listening to the traffic. So first, we have some DNS packets to find out the IP address of the visited site. We'll look at these kinds of packets soon, but right now let's just have a brief look. So a DNS query for the IP version 4, another DNS query for IP version 6, don't worry about the versions right now. We'll cover them soon, I promise. These DNS queries are transferred as UDP packets in transport layer. The destination port is 53. This is the IP packet with the source and the destination IP addresses. So we'll go through the layers one by one, and we'll see all these packets, datagrams, and frames in detail. So we'll keep going. This is the structure of the Ethernet frame. First, there are two DNS queries for www.hackeracademy.uk. One for the IPv4 address, and the other one is for the IPv6 address. And because the website is redirected to hackeracademy.uk, there are two more DNS requests for this address. Next, DNS packets are the DNS query responses. This response is type A. That means it's an answer for the IPv4 request. And here's the answer, the IP address of the website. Now, DNS response packet uses UDP at the transport layer, IP at the network layer, etc. Here we have a TCP handshake between Kali and the web server. We'll also see this in detail later on. A SYN packet, a SYN-ACK as a reply, and an ACK packet to complete the handshake. This is an HTTP GET request. We learned the IP address of the website, and now the system is ready to receive the web page. HTTP protocol and application layer. Now you can see the headers and the parameters of the request. TCP protocol and transport layer, source port, destination port, flags, etc. IP protocol in network layer. Here are the source and destination addresses. And Ethernet frame in layer 2. These are the TCP packets, which will build the HTTP response. So in this example, it's the web page. In other words, the response is transferred between the web server and our system as fragmented packets in transport layer. Here's the HTTP response, 200, okay. So the web page is received. And here's the data, which is our web page. These are the response details, response type, headers, etc. Here, there's additional information produced by Wireshark, which says that the HTTP response is created by reassembling 5 TCP segments or packets. So now I'd like to show you the difference between that and HTTPS traffic. So I'll go to the browser and visit an HTTPS page now. But before visiting the page, let's start Wireshark. Here's the start button. Continue without saving. Okay, now we have a clean sheet. So I'll go to the browser and hit enter. Wow, lots of packets in milliseconds. So we've got plenty of packets to investigate. Just click the stop button once again. Okay, so the DNS request and the response packets first. Here is a response with an IPv4 address. Here there's a TCP three-way handshake between Kali and port 443 of Google's web server. And now a client hello TLS packet to start the TLS handshake, again between Kali and Google's server. Now to get rid of the other traffic records, I'd like to filter the results by the IP address of the Google server. Now, while the mouse pointer is on the server IP address, right-click and go to Apply as Filter and select the Selected option. So as you can see here in the filter bar, the IP address is assigned as the destination IP address. Now, we only have to see the traffic where the destination is the Google server. But we'd like to see both the incoming and the outgoing traffic. So I'll change the DST part of the filter to ADDR and click the blue arrow to activate the new filter. Now we can see the traffic in both directions. Okay, so here we are at the Hello TLS message. Here are the details of the message. TLS uses TCP protocol in transport layer. The Google server replies a server hello message as the second step of the TLS handshake. Then comes the certificate and server key exchange, and the server hello done message is sent by the server. Kali sends the client key exchange, Google server sends the new session ticket, and the encrypted communication starts. Here is some encrypted application data, which is meaningless for others who listen to the traffic. And as you can see here, the message is encrypted at the application layer, so you can still see the source and the destination addresses, the ports, etc. This is how an IPv4 packet is seen on Wireshark. So it's a DNS query response. The fields we mentioned are seen pretty clearly. Version is 4. Header length is 5 words, which means no options field. Total length is 96 bytes. MF and DF flags are not set. And you can see the source and the destination addresses and all the rest. So have a look at what you see here. There are a lot of packets that Wireshark captures in seconds. There are some requests and responses for them, broadcasts and their replies, and etc., etc. There is an easier way to follow a stream, although this is very entertaining. The stream is a collection of packets that form a network conversation from the beginning to the end, just like your favorite story. So I'm in Kali now, and I captured the traffic just for a little bit. And while I was capturing, I visited a website to create some HTTP traffic. And here are the results: DNS packets, TCP packets, HTTP packets, etc. So I'll select an HTTP packet, and it's the GET request. Right-click, go to Follow on the submenu, and here you see the TCP stream and the HTTP stream options are both enabled. So that means we can follow either the TCP stream or the HTTP stream. So let's click HTTP stream. Now the client packets are red and the server packets are blue. The GET request by Kali, 200 OK response by OWASP BWA, Now, this is a return page in HTML format. So you can scroll down and we'll see some of the other requests and the responses in the same stream. And perhaps you're beginning to see that when you click on a link in a website or visit a website by typing its URL, there might be several consecutive requests and responses that you don't even realize. But in actuality, you don't need to know them as the end user, but we're not your typical end users now, are we? So let's keep going. From the combo box at the left-hand side of the bottom of the stream window, you can filter the conversation from one side to another or vice versa. So at the right-hand side, there is another combo box where you can select the output format. Now when you close the stream window and go back to the main window of Wireshark, you can see that the stream filter is applied right here. So I'll remove the filter by clicking this cross icon. Now I see the entire captured traffic again. That is why filters exist. So in typical traffic capturing on a network interface, there are a lot of packets received from and delivered to all over the network and, well, the internet as well. So let's see how we can take a picture of that network. Let's go to Kali and start Wireshark. You can start Wireshark from the Applications menu or open a terminal window and type Wireshark to start the app. Don't worry about the ampersand and the and of the command. Putting an ampersand at the end of a command causes the shell to run the process in the background. It's sort of multitasking. You can have many processes running, but only one in the foreground at any given point. The process in the foreground is the process that appears to have locked up the terminal. Whatever. The first message is because we are a super user on Kali. No worries. Okay, the welcome page of Wireshark asks which interface we would like to listen to first. So let's have a look at the interfaces of our system. To look at the interfaces and to remember the IP address of Kali, open a terminal and type ifconfig. There are two result sets of the ifconfig command, eth0 and lo. eth0 is the first Ethernet interface. Additional Ethernet interfaces would be named eth1, eth2, etc. Here we have only one. Now lo is the loopback interface. This is a special network interface that the system uses to communicate with itself. eth0 is the interface that we're interested in at the moment. Double-click to open the eth0 on the main page of Wireshark to start capturing the packets passing through our Ethernet interface. Now, to speed it up, let's create some network traffic. Open one of my virtual machines, OWASP BWA, and ping Kali. To stop ping command, press Ctrl-C, ifconfig, to learn the IP address of the machine. Now I go to another VM, Metasploit, and ping the last VM first. And then ping Kali. Here we have a lot of ICMP and ARP traffic at the moment. So let's generate some traffic. I open the browser in Kali and visit the website served by the OWASP BWA machine. And even more traffic. I visit nhs.uk, my favorite website. Okay, that's enough. Let's turn back to Wireshark. As you see, we have a lot of packets captured, and new packets arrive every second. ARP packets, TCP packets, TLS packets for HTTPS traffic, etc. Here we don't investigate the packets in detail. We want to learn about the systems which are interacting with us. So go to Statistics menu and select Conversations. There are 5 tabs in the Conversation window by default. And we're on the IPv4 tab at the moment. Here there are IP packets grouped by address A and address B. In each line, we see how many packets sent up to now, total size of the packets in bytes, number and size of the packets from A to B and from B to A, etc. There is traffic between 8.8.8.8 and my colleague. Now I know that 8.8.8.8 is the IP address of Google DNS, so I must have set the Google DNS as the DNS of my colleague. I'd like to look at the network config. And yes, my DNS address is 8.8.8.8. In the Ethernet tab, we can see the MAC addresses of the systems. The addresses full of Fs mean that the packet is broadcasted. ARP requests are the examples for these kind of packets. In the TCP tab, we can see TCP packets grouped by the addresses and this time by ports as well, because a system may have different interactions with any other system. For example, Kali may have HTTP traffic through port 80, and at the same time, it may have an SSH connection through 22 as well. Same as TCP. Packets are grouped by IPs and ports in the UDP tab. Here we have learned a lot of live systems, IP addresses, and MAC addresses just listening to the traffic go through our network interface. If you'd like to investigate the traffic between the two machines, select the line, right-click. If you choose Apply as Filter from the menu, only these kinds of packets will be seen in Wireshark. I'll choose Find at this time. As you see, automatic query string is prepared. I can navigate between the packets by clicking the Find button. Go back to the conversation window. At the bottom right, there is a Conversation Types button. When you click on it, a lot of different protocols are listed. These selected 5 are the default selected protocols. You can add any protocol from the list. When you select one of them, a new tab is added to the conversation window.
HTTP traffic. HTTP, or Hypertext Transfer Protocol, is a commonly used port for the World Wide Web and used by some websites. However, its encrypted counterpart, HTTPS, is more common, which we will discuss in the next. HTTP is used to send, get, and post requests to a web server in order to receive things like web pages. Knowing how to analyze HTTP can be helpful to quickly spot things like SQLi, web shells, and other web-related attack vectors. HTTP traffic overview. You should already have a general understanding of how HTTP works before completing this lecture. HTTP is one of the most straightforward protocols for packet analysis. The protocol is straight to the point. We can see a sample HTTP packet. Looking at an HTTP packet, we can easily gather information since the data stream is not encrypted like the HTTP counterpart, HTTPS. Some of the important information we can gather from the packet is the request URI, file, data, and server. Now that we understand the basic structure of an HTTP packet, we can move on to looking at a sample HTTP packet capture to get hands-on with the packets. Practical HTTP packet analysis. To get an understanding of the flow of HTTP packets and get hands-on with the packets, we analyze the http.cap file. After opening the PCAP, we can see that this is just a simple HTTP packet capture with a few requests. Navigating deeper into the packet capture, we can look at the details of one of the HTTP requests. From this packet, we can identify some very important information like the host, user agent, requested URI, and response. We can use some of Wireshark's built-in features to help digest all of this data and organize it for further future analysis. We can begin by looking at a very useful feature in Wireshark to organize the protocols present in a Capture the Protocol hierarchy. Navigate to Statistics Protocol Hierarchy. This information can be very useful in practical applications like threat hunting to identify discrepancies in packet captures. The next feature in Wireshark we will look at is the Export HTTP object. This feature will allow us to organize all requested URI in the capture. To use Export HTTP object, navigate to File, Export Objects, HTTP. Similar to the protocol hierarchy, this can be useful to quickly identify possible discrepancies in capture. The last feature we will cover in this section of this lecture is endpoints. This feature allows the user to organize all endpoints and IPs found within a specific capture. Just like the other features, this can be useful to identify where a discrepancy is originating from. To use the endpoints feature, navigate to Statistics Endpoint. HTTP is not a common protocol to see too much as HTTPS is now more commonly used. However, HTTP is still used often and can be very easy to analyze if given the opportunity.
Now, HTTPS consists of communication over HTTP within a connection encrypted by TLS, Transport Layer Security, or its predecessor, SSL, the Secure Sockets Layer. The main motivation for HTTPS is authentication of the visited website and protection of the privacy and integrity of the exchanged data. So let's see how a typical encrypted connection between the server and the client is established. The client sends the information that the server needs to communicate with the client using SSL. This information contains the client's SSL version numbers, cipher settings, and session-specific data. The server then sends the information that the client needs to communicate with the server over SSL. The server also sends its own certificate. The client uses the information sent by the server to authenticate the server. So using all data generated in the handshake thus far, the client creates the pre-master secret for the session, encrypts it with the server's public key, and then sends the encrypted pre-master secret to the server. The server uses its private key to decrypt the pre-master secret, and both the client and the server perform a series of steps to generate the master secret. Then, they use the master secret to generate the session keys, which are symmetric keys used to encrypt and decrypt information exchanged during the SSL session and to verify its integrity. The client sends a separate message indicating that the client portion of the handshake is finished, and the server sends a separate message indicating that the server portion of the handshake is finished. And then another thing in a policy is to identify how many passwords are transmitted. So even by having a strong password, if it's not carried securely, it can be exposed. So while transmitting a password, the application should use encryption. And this is, of course, HTTPS. But not only passwords, but any other sensitive data, such as payment information. So this brings us to yet another problem that we're going to cover in session management. HTTPS shouldn't only be used on login pages, but the entire application. So go to Kali and open up your terminal. And we're going to capture network traffic to watch for credentials that are transmitted. So open up Wireshark by typing, and then open up your browser. I'm going to just dock it over here to the right side and go to the BWAP login page. Now, before you log into BWAP, start capturing the traffic on your network interface. So in my case, it is ETH1. So I'll choose it and start a capture by clicking this icon on the toolbar. And then go to the login page. Enter username and password, hit login button. Okay, so we logged in. So now let's go to Wireshark. Now, here's a place that you apply display filters on the capture traffic. So simply type HTTP to view HTTP traffic. As you can see, the first line is the login request that we sent. Click it to choose, and below you can display details about this line. So under this node, there are HTTP-related data. And under this node, you will see the form data has been entered.
And you can see it is in clear text. So anyone on the same network can sniff this data. You can also right-click on this line and follow the TCP stream, and then view the HTTP traffic data as we see it in Burp. Okay, so now I'm going to close this window and stop capturing. Let's return to the browser again. This time, go to an HTTPS web application, and I'll just open the Twitter login page. And I'll get me a fresh capture. Okay, so enter in some login information here and log in. And you see Wireshark again is capturing the traffic. But this is not raw HTTP. It is encrypted traffic. So I'm going to filter SSL only traffic. And you can see the protocol. It is TLS version 1.2. So this means the data is encrypted. Choose a new line. And from the below pane, open Secure Socket Layer node. And here is the encrypted application data sent over the network. So if you follow TCP stream, you won't see anything. So obviously the point here is, as a pen tester, we need to check if the application data is sent over a secure channel or not. All right? So now we need to report, and we can benefit from this finding as well.
TCP dump is a free open source, very common and fast packet analyzer that runs under the command line. It prints out a description of the contents of packets on a network interface that match the Boolean expression given as a parameter. TCP dump has a lot of filtering options. We'll discuss some of them in the next slide. It can be preferred to the other packet analyzers, such as Wireshark, because it's so fast. It also supports some of the most common network traffic capturing format, PCAP. You can save the results as raw ASCII text in a document as well. So have a look at this. These are some of the parameters you can use with the TCP dump command. D, or list interfaces, prints the list of the network interfaces available on the system and on which TCP dump can capture packets. I, or interface, listens in on the interface. If unspecified, TCP dump searches the system interface list for the lowest numbered configured interface, excluding loopback, which may turn out to be, for example, ETH0. N means do not convert addresses, that is, host addresses, port numbers, etc., to names. V produces verbose output when parsing and printing. The more V, the more details. W writes the raw packets to specified file rather than parsing and printing them out. R reads packets from the file which was created with the W option or by other tools that write PCAP or PCAPing files. A prints each packet in ASCII. Handy for capturing web pages. When parsing and printing, in addition to printing the headers of each packet, capital X prints the data of each packet in hex and ASCII. This is very handy for analyzing new protocols. So if you use the X option, the data of each packet is printed in hex. In addition to these options, you can filter the results in several ways. If you would like to monitor a specific protocol, such as TCP, you can use its name as the filter. You can capture packets to or from an endpoint residing in the network using net filter, or use host filter to see the packets of a host as a source, destination, or either one. Use the port to filter TCP or UDP packets sent to or from a specified port. Use port range to listen to ports in any given range. Now, if you use the SRC option, you can see only the packets where the target system is the source of the packets. Similarly, DST is used to specify the destination system. So, of course, you can use more than one filter in a command and set up the relation using and or as logical operators. For example, host is 1.1.1.1 and port is 80. Now, before running several TCP dump commands, let's examine the fields of a typical TCP dump output row. The row shown in the slide is a TCP packet. The first field is the time when the packet arrived, with a timestamp as hour, minute, second, and, well, the fractions of a second. So the second field is a protocol running atop the link layer, in this case, IPv4. Now for IP packets, the third field is the IP address or host name of the host sending the packet, along with, for TCP and UDP packets, the source port. The packet on the slide came from port 80 of the system 172.16.99.139. Now the fourth field is the IP address or host name of the host receiving the packet, along with, for TCP and UDP packets, the destination port. Flags is the TCP segment flag. The packet on the slide doesn't have any flags set other than ACK. ACK is the acknowledgement number in the packet. TCP dump shows sequence and acknowledgement numbers relative to the initial sequence number by default. Win is the source host's TCP window, and you see the options field. Length is the length of the data in the TCP segment. Length here is 0, so that means that no data is exchanged yet. So that's enough for now. Let's see TCP dump in action. Time for hands-on. So we're going to use Kali for this demonstration, and we're going to need another system. So here I have OWASP Broken Web Applications VM, which is one of my VMs. And it has a web application, and the web server is running by default. So first, I want to sniff the entire traffic passing through the ETH0 interface, right? TCP dump is embedded into Kali, so we're ready to use it. If you type TCP dump and then hit enter, it starts to listen to the traffic. And by default, it listens to the interface of the ETH0, and that's exactly what we want right here. So right, there's no traffic at the moment. So let's make some noise. I'll go to the OWASP BWA and ping Kali. Now turn back to Kali, and yes, here we have the packets caused by the ping command. ICMP echo requests and replies. And there are some other packets too, and of course, ARP requests and the responses before them. So we can limit the number of received packets using the C parameter. The command stops when it receives specified number of packets, and here it stops after the fifth packet. And having a look at the results, we see the domain names of the source and the destination systems. It's especially good for remote systems outside the network, but we may want to see the IP addresses of the systems instead of the domain names. So to do this, we can use the N parameter. And now the computers are listed with their IP addresses. Okay, so let's turn back to the first example. We were listening to the ETH0 interface. And like I said before, it listens to this interface if the interface is not specified. And we can specify the interface we want to listen to by using the I parameter. Use I with the name of the specified interface, ETH0 in this example, and hit enter. Now the second example, let's sniff only the TCP traffic between us and a target host. TCP dump is the command itself. Host parameters specify that the target host and TCP is a protocol we want to listen. So it started to listen to the TCP packets between Kali and OWASP BWA. We have no TCP traffic at the moment, so let's create some. So I'll open a browser window and visit the web page hosted on OWASP BWA. Now turn back to the terminal screen, and whoa, we have a lot of TCP packets caused by HTTP requests and responses. Now we didn't use the end parameter, so we see the domain names and the service types, such as HTTP, instead of the port numbers. Now let's run the same command once again, but with the end parameter. So I'll go to the application and just click an arbitrary link to create some traffic. Now back to the terminal. See, look, the traffic with IP addresses and their port numbers. So in the third example, let's have a look only at the IP traffic received from the target host. And right, if we don't enter any parameter, we will see the IP packets received from the target host. However, we see a lot of different packets here as well. So now I'll show you how to filter the received packets. So to see only the received packets from the target host, we use SRC. So it's basically a keyword SRC before the host parameter. Now the host IP and the IP keyword to filter the IP packets. And look at that, as soon as we hit enter, we start to receive some packets because the ping command in the OWASP BWA is still running. We see the ICMP echo requests, but we don't see the ICMP responses because we used the SRC keyword before the host, and we wanted to see only the received packets from the target host. So that's as it should be. Now let's go to the web app and click any link to create some HTTP traffic. And here are the IP packets of the HTTP requests. Now you can press Control and the C key to stop the command. So in this next example, let's filter the TCP traffic of the entire network generated by HTTP requests and responses. So the net parameter to define the network, specify the network, and here it's 172.16.99.0/24. And to filter the HTTP traffic, we can specify port 80. So here we assume that the applications are using the default port, which is 80. Okay, so we'll start to listen. Now I'll go to the web browser and click any link to create the HTTP requests. And here is all the TCP traffic sent to or received from the default port 80. So what would happen if we didn't use the port parameter? Well, as you can see here, we would see the ICMP echo requests and replies as well because the ping command is still running in the OWASP BWA system. So lastly, let's see the SSH traffic from a specified host to another one. First, I'll go back to OWASP BWA and check if the SSH service is running. Use service SSH status to check it. Yep, SSH service is running on OWASP BWA. So to see the port that SSH listens to, you can use the netstat TNLP command. And as you see here at the top of the screen, SSH listens to the port 22, the default port for SSH. So in Kali, I'll open another terminal screen and create an SSH connection between Kali and OWASP BWA. Type SSH root at the IP address of OWASP BWA and hit enter. Enter the password of the root user of OWASP BWA, which is, remember, OWASP BWA, as long as you haven't changed it. And here we have an SSH connection. So I'll go to the other terminal screen to create the TCP dump command. src host to specify the source host, and dst host to specify the destination host, and port. So now go to the SSH connection and send something to the OWASP BWA. Hey, look at that. See, so we capture the packets in every keystroke. The packets are from Kali to the port 22 of OWASP BWA. And I'm sure you saw it like I did because we wanted to see the traffic only if the source host is Kali and the destination host is OWASP BWA. We don't see the SSH packets received from OWASP BWA. To see both sent and received packets, we can change the command to something like this: TCP dump host 172.16.99.139 and port 22. Now we'll see the received packets as well as the sent packets. HPing is an excellent command line-oriented TCP/IP packet assembler analyzer. The interface is inspired by the ping 8 Unix command, but HPing isn't only able to send ICMP echo requests. It supports TCP, UDP, ICMP, and raw IP protocols, has a traceroute mode, the ability to send files between a covered channel, and many other features. So a subset of the stuff you can do using HPing: firewall testing, advanced port scanning, network testing using different protocols, TOS, fragmentation, manual path MTU discovery, advanced traceroute under all the supported protocols, remote OS fingerprinting, remote uptime guessing, and don't forget TCP/IP stacks auditing. HPing can also be useful to students that are learning TCP/IP. Although it's a packet analyzer tool, it's widely used for DOS, denial of service, tests, and attacks to create IP-spoofed packets and send them to the target system. Let's see how we can use the hping command to scan the network simply. Go to Kali and open a terminal screen. hping3 is embedded into Kali and defined in the path, so you can use it anywhere, just typing the name of the command, hping3. Type hping3-h or hping3-help to see the detailed usage of the hping3 command. Let's look at a few parameters important for scanning mode. Under the mode title, we have a scan mode, and the help shows a sample usage of the mode as well. We'll use scan or 8 parameter to use hping and scan mode. Under TCP UDP title, we have the parameters to set the flags of TCP or UDP packets. Well, you'll see the flags and meaning in this course in following lectures, so just see the hping in action now. For example, uppercase S, or SYN parameter, is used to set the SYN flag of TCP or UDP packets. Let's prepare the hping command to make a network scan. The first parameter is scan, to use hping in scan mode. Here we should say in which ports we will scan. In this example, 0 to 500 means that the ports between 0 and 500 will be scanned. You can give a port range like this with a dash between the lower bound and the upper bound, or you can give the ports one by one, separating them by a comma, or you can use a combination of these two. Now I want to set the SYN flag of the packet, because all TCP connections start with a SYN packet. Well, again, we'll show you how a TCP handshake is made later on in the following lectures. Here comes the IP address to scan. Hit Enter to start the scan. Here we have the responding ports, and the flags column says what the reply is. We sent SYN packets and get SYN ACK packets. That means ports are accessible and open to us. Now let's make another scan. This time, I'll use uppercase X to make a Christmas scan. In the scan, push, urgent, and fin flags are set in the packet, which is not seen in regular traffic. Since the packets they received are not valid packets, they've dropped them and returned no response. Although it's not the subject of our course, because it's very common usage, I'd like to show you how to perform an IP-spoofed DOS, or denial of service attack, using the hping tool. I'm going to attack my own server. First, I'll test if I can connect to the application. So open a terminal screen and ping the application www.owasp.bwa.com. Okay, I have a connection through the application. Open a browser and visit the website. Here I click a few links to show the response time of the server. Oh, okay, it's really fast. It responds as soon as I click onto links. Now let's prepare the hping command to prepare a DOS attack. The first parameter of the command is -flood. You know what? Let's run hping3-help in another terminal screen to see the meanings of the parameters. Flood parameter is used to send packets as fast as possible. To make it a SYN flood attack, I set the SYN flag using -s parameter. When I send a SYN packet, since it's a legitimate TCP handshake starter, the server will try to respond to all the packets at the start of the TCP communication. So the server will be very, very busy. -v is to open verbose mode. That means we'd like to see the results of sent packets. The next parameter is rand source. This parameter will randomize the source IP addresses as if they are requested by different systems. So the attack is distributed denial of service now. And since the IP addresses are random, the victim doesn't know about you. Give the target domain as a last parameter. Oh, by the way, the order of the parameters is not important. Hit Enter to start the attack. Now, because we're in flood mode, no replies is shown. Let's try to click a few links to see the response time of the server while it's under attack. Click a link. It's waiting. It's obviously slowed down. Maybe our request will be timed out? So this is how a simple denial of service attack is performed. I'll stop the flood by stopping the run of the command using Control-C keys. As you see, in less than a minute, we sent more than 1 million SYN packets to the victim server. No packets received because we randomized the source IP addresses of the packets. That means the responses were sent to different IP addresses. This is why we didn't receive any packets. Since I stopped sending packets, the server is now responding in good time again. Now let's repeat the attack while Wireshark is running to see what's happening under the hood. Start Wireshark. Since we're using the ETH0 interface of Kali, I'll double-click the ETH0 on the home screen to start to listen to the traffic passing through the ETH0 interface. There's still some packets on the queue because of our previous attack. I restart capturing by pressing the green button at the upper left corner of Wireshark to clean the screen before the second attack. Continue without saving. Okay, Wireshark is running and clean. We're ready to repeat the attack. You can see the number of packets at the bottom of Wireshark. As you see, we sent hundreds of thousands of packets in seconds. Nmap, Network Mapper, is a free and open source utility for network discovery and security auditing. Many systems and network administrators also find it useful for tasks such as network inventory, managing service upgrade schedules, and monitoring host or service uptime. Nmap runs on all major computer operating systems, and official binary packages are available for Linux, Windows, and Mac OS X. Nmap has been used to scan huge networks of literally hundreds of thousands of machines. Nmap is usually very good at documentation. Significant effort has been put into comprehensive and up-to-date man pages, white papers, tutorials, and even a whole book. You can visit nmap.org to find out more about Nmap. While Nmap comes with no warranty, it is well supported by a vibrant community of developers and users. It's one of the most well-known tools of the network security domain, and indeed, with a lot of facilities, it's very powerful. In addition to the classic command line Nmap executable, the Nmap suite includes an advanced GUI and results viewer, Nmap, a flexible data transfer, redirection, and debugging tool, NCAT, a utility for comparing scan results, NDiff, and a packet generation and response analysis tool, NPing. Nmap uses raw IP packets in novel ways to determine what hosts are available on the network, which ports of these hosts are accessible, what services those hosts are offering, what operating systems are running, what type of packet filters, firewalls are in use, and dozens of other characteristics. Beyond all this, Nmap has its own scripting engine and allows developers to develop new modules. In the following lectures, to discover the network, we'll perform the following with Nmap. First, we'll use ping scan to find out the hosts in the network. Then we'll use different types of port scan to find the open or accessible ports. We'll detect the services running on the ports and their versions. We'll try to learn the operating systems running on the systems. And after that, we'll see how to use scripts with Nmap scans. And we'll learn some important scripts as well. Nmap sends some packets to discover the network. To prevent security devices from blocking our packets, here's where we're going to learn some timing tricks. Then we'll see what we can do more of to bypass security devices such as packet filters, IDS, or IPS. Here, there's an Nmap command example. Let's see some basic parameters of the Nmap command. Nmap is, of course, the command itself. S is to define the scan type. If you use S with uppercase T, as seen in the slide, it means you want to run a TCP scan. We'll see the important scan types in detail. If you don't use this parameter and you have the administrator privileges on the computer where you're using Nmap, SynScan is a default scan type. If you don't have the admin privileges on the computer, TCP scan will run. Destination IP address is the only required parameter to run this command. It means you can run the Nmap command like nmap 172.16.99.139. This is the IP address of the target machine which you want to scan. You can either give a single IP address or give an IP block or an IP range as a target, but we'll see that soon. Destination ports are the port numbers that you want to scan. If the target port numbers are not given to the command, top 1,000 ports will be scanned. Be careful, I didn't say the first 1,000 ports. I said the top 1,000 ports. That means the most used 1,000 ports will be scanned. There are different ways to enter destination ports, and we'll see them in detail. One of the very first steps in any network reconnaissance mission is to reduce a set of IP ranges into a list of active or interesting hosts. Scanning every port of every single IP address is slow and usually unnecessary. In No Port Scan option, using SN option, which was known as SP in previous releases, you tell Nmap not to do a port scan after host discovery, and only print out the available hosts that responded to the host discovery probes. This scan type is often known as a ping scan. Systems administrators often find this option valuable as well. It can easily be used to count available machines on a network or monitor server availability. This is often called a ping sweep and is more reliable than pinging the broadcast address because many hosts do not reply to broadcast queries. The default host discovery done with SN is executed by a privileged user. It sends an ICMP echo request, TCP SYN packet to port 443, TCP ACK packet to port 80, and an ICMP timestamp request by default. When executed by an unprivileged user, only SYN packets are sent using a connect call to ports 80 and 443 on the target. When a privileged user tries to scan targets on a local Ethernet network, ARP requests are used unless send IP was specified. Let's perform the first Nmap scans of the course using ping scan, also known as no port scan. Nmap is embedded in Kali and defined in the path, so you can run Nmap from anywhere just by typing Nmap in a terminal screen. When you type Nmap and hit Enter, you get the help page of the Nmap. You can also look at the man page by typing man Nmap to learn more. Let's build an Nmap command to perform a ping scan. After the command itself, Nmap, I first add the parameter to define the scan type as ping scan. Note that the order of the parameters is not important in Nmap. Now, enter the only mandatory parameter, IP address. Here I enter 172.168.99.0/24. Network gurus already know what it is. Keeping it very simple, it means the IP addresses between 172.16.99.0 and 172.16.99.255. That's enough. Hit Enter and run the command. And the results are in. These are the hosts which are up. That means these are the systems that responded to our requests. Remember from the previous slide, our requests are ICMP Echo, SYN for port 443, ACK for port 80, and ICMP timestamp requests, if the user is privileged. The IP addresses or the domain names of the systems are spread across the lines. In most cases, we want to see the IP addresses of the hosts as a list to use in further scans. So what can we do to see only the IP addresses of the live systems? Well, we're going to use the power of the Linux command shell. First, let's clear some lines of the result which do not contain IP addresses. So I'll only have the lines of IP addresses. To be able to do this, I'll use grep command with pipe. Copy a static part of the IP lines, for example, nmap scan, and give it as the parameter of grep command. Let me give you a little tip here. If you're using a mouse, select a string in the terminal screen and press the middle button of the mouse to copy and paste the selected part. Now we only have the lines which contain the IP addresses. But wait a second, we have a domain name of a host. Let's get rid of the domain name and see only the IP address of it. In nmap command, add -n parameter to avoid the name resolution, so nmap will display only the IP address. Now we have the lines with IP addresses. Now the second step is to clear the words in the lines to have only the IP addresses. To do this, we'll use the cut command of the Linux shell. Type cut. The delimiter here is the space character. Give it with the D parameter. IP is the fifth field of the line. Give it with F parameter. Now we have the IP list of the live hosts. Port scan with Nmap allows you to discover which TCP or UDP ports are open on your target host. Network ports are the entry points to a machine that is connected to the Internet. A service that listens on a port is able to receive data from a client application, process it, and send a response back. Malicious clients can sometimes exploit vulnerabilities in the server code so they can gain access to sensitive data or execute malicious code on the machine remotely. That is why testing for all ports is necessary in order to achieve a thorough security verification. Port scanning is usually done in the initial phase of a penetration test in order to discover all network entry points into the target system. Port scan takes the biggest part of our Nmap lectures. In what I would call the most basic port scan types lectures, we see the following: Nmap options of port scanning, SYN scan, TCP scan, comparison between the SYN scan and TCP scan, UDP scan, and some other types of port scans. SYN scan is the default and the most popular scan option for good reasons. It can be performed quickly, scanning thousands of ports per second on a fast network, not blocked by restrictive firewalls. It's also relatively stealthy, since it never completes TCP connections. It also allows clear, reliable differentiation between open, closed, and filtered states. This technique is often referred to as half-open scanning, because you don't open a full TCP connection. You send a SYN packet, as if you're going to open a real connection, and then wait for a response. A SYNAC indicates the port is listening, or open, while a RIST, reset, is indicative of a non-listener. If no response is received after several retransmissions, or an ICMP unreachable error is received, the port is marked as filtered. If you receive a SYNAC from the target system, you send RIST instead of the ACK packet, and you do not complete the three-way handshake. Okay, so let's perform an Nmap SYN scan in our virtual network. Go to Kali and open the terminal screen. First, let's look at the IP address of Kali to understand the IP block. Here, my IP block is 172.16.99. This is because the net mask is 255.255.255.0. I don't want to go further into network basics in this course. You know what? Okay, fine. I'm going to add an IPv4 document to the course resources. You can look it up there. Now, let's create the SYN scan command. Nmap is the command itself. S is to SYN scan. Since it's the default scan type for privileged users, and I'm already a privileged user in Kali, this parameter is not necessary for a SYN scan. Now, here is the target IP block, 172.16.99.024. As we talked about before, remember, this is the IP address block from 172.16.99.0 right the way through 172.16.99.255. And let's keep it a fast scan for just the top 50 ports. I use top ports parameter for this purpose, and hit enter. Now let's look at the scan results. Here we have the computers who have the IP addresses 172.16.99.1 and 2. These are the gateway and the DNS server for my virtual network, VMnet. Ignore them for now. In fact, 1 is my host machine at the same time. Here there is a system, and the open ports are in the top 50. Well, look, there's another machine, and of course, it's open ports. The machine with IP 254 is the DHCP server of my VMnet, so ignore that as well. And the last machine found is the Kali itself. Okay, let's open Wireshark and see what's happening when a SYN scan is performed. Run Wireshark first. Double-click ETH0 to start to listen to that interface. Now to skip the packets, which we are not interested in, I add a filter. I only want to see the traffic for my destination computer, 172.16.99.139. And I want to see the TCP traffic only. Click the blue arrow next to the filter bar to activate the filter. Okay, now go to the terminal screen. I'd like to analyze the SYN scan packets for an open port first. 172.16.99.139 is my destination system, and I know that port 80 of that system is open. Hit enter and run the Nmap query. Yep, the port is open just as I remember. So now go back to Wireshark. I want to stop Wireshark by clicking the red square at the upper left corner to avoid unwanted packets. So here we have 3 packets. The first packet is from an arbitrary port of Kali to the 80th port of the system 139, the destination system. It is a SYN packet to start the three-way handshake. The second packet is a SYN-ACK, sent by the destination system. The third packet is a RIST sent by Kali. Because it's a SYN scan, the three-way handshake is not completed and corrupted by a RIST packet. Now I restart the Wireshark packet capturing to clean its screen by clicking the upper left blue button. Okay, so this time I scan a closed port, for example, port 81. Now the first packet is a SYN scan packet to start the three-way handshake again. The source system is Kali, and the destination system is, again, 139. The second packet is, for this scan, a wrist packet. Because port 81 is closed, the destination system sent us a wrist packet. Let's see how Nmap interprets the results of SYN-scan. When we send a SYN packet, the destination system replies a SYN-ACK packet to show that it's ready for a connection. And we send wrist to corrupt the handshake. Nmap interprets this result as the port is open. If the destination system replies a wrist packet for our SYN packet, that means the port is accessible, but it's closed. If the destination system doesn't respond to our SYN packet, Nmap thinks that the packet is dropped or filtered. It's a common behavior of the firewalls. If the destination system replies an ICMP unreachable packet for our SYN packet, again, it's interpreted as filtered. This is another type of firewall behavior. Well, what do open, closed, or filtered actually mean? Let's take a closer look at the results of Nmap. When Nmap sends packets to a port and receives a positive response, the port is assigned the state of open. For example, SYN-scan receives a SYN-ACK from the destination system if the port is open. If Nmap determines that a port is not available, it assigns it the closed state. This signifies that Nmap has received a result that clearly shows that the port is closed. A SYN-scan receiving a wrist in response to a port query is an example of a closed port. Filtered ports are the result of a packet filter or firewall when no response at all is received from the remote device. The port is considered to be filtered. Since a response isn't received from the port, Nmap often retries communication to the port to ensure that the packet wasn't simply dropped due to error or congestion. Please note that this type of response is categorized differently if this is a different scan type, such as a UDP scan or a FIN scan. The next result, open filtered, is coming in a minute. On the other hand, if the destination systems return an unexpected response, again the port is considered to be filtered. If we get an ICMP unreachable response in a SYN scan, the port is flagged as filtered. Now, in some cases, the lack of a response may not necessarily mean that a port is filtered. Lack of a response might mean that the port might also be open. Now, in these situations, Nmap signifies that the port is either filtered or open. For example, in a UDP connection, in most cases, the destination system does not send a response when it receives a UDP packet. So if the destination system does not respond, Nmap categorizes it as open filtered. Make sense? In this slide, you see some of the most known default ports. So here's the question. If the port 22 is open, is the service running there absolutely in SSH? Could there be another service? Well, these are the default port numbers of the services. You can run any service in any port. You can run HTTP on port 22, for example. But for the ease of use, the default ports are used in general. So if you're performing a pen test, you should probably look at the well-known ports first, but you should never just scan the default ports. There are different ways to scan ports with Nmap. Let's see how we can scan ports. Let's prepare a SYN scan for a Metasploitable device. The IP address of my Metasploitable is 172.16.99.206. If you do not use any one of the port scanning parameters, top 1,000 ports are scanned. Top ports are the most used ports in general. The first way of choosing the ports to scan is using P parameter. After entering the scan type and target IP, enter the port numbers with P parameter. You can enter ports one by one, separated by a comma, or you can give a range of ports by putting a dash between the port numbers. In this example, the ports 22, 80, and the ports between 100 and 200 are scanned. If you perform both TCP scan and UDP scan in a single Nmap query, you can choose both the UDP ports and the TCP ports using P parameter. For this Nmap scan, we'll use both SynScan and UDP scan at the same time. We haven't seen it yet, but the UDP scan is performed using S capital U parameter. And as you know, the SynScan is a type of TCP scan. After entering the target IP, put -P. To enter TCP ports, put uppercase T with a colon just after the parameter P and the TCP ports to scan. Same as giving port numbers directly with P parameter. You can enter ports one by one, separated by a comma, or you can give a range of ports by putting a dash between the port numbers. To specify the UDP ports, put U, that's an uppercase U, with a colon and the ports with the same format. For this example, let's scan the TCP ports 22 and 80, and the UDP ports 53, and the ports between 139 and 150. So here are the results, TCP ports first and then UDP ports. Another way to specify the ports is using top ports parameter. Using this with the number of ports that will be scanned, you can scan the top ports within this parameter. So let's scan top 20 ports for this example. So here are the top results of the most used 20 ports. If you use uppercase F, which means fast scan, top 100 ports are scanned. So let's perform an Nmap SynScan with F parameter here. And open another terminal screen and perform another Nmap scan using top ports 100 parameter. As you see, we get the same results because these are the same queries. If you'd like to scan all the ports of the system, well, you should scan all the ports of the systems in a pen test. You have to use the P parameter with the interval from 1 to 65,535. This is the range of possible port numbers. Prepare the Nmap SynScan query with the destination IP address. Now put P1-65535 and hit enter. Here are all the open ports of Metasploitable. By default, Nmap does host discovery and then performs a port scan against each host it determines is online. If you use PN in the Nmap query, you skip host discovery and port scan all target hosts. Disabling host discovery with PN causes Nmap to attempt the requested scanning functions against every target IP address specified. So if a Class C target address space, that means 24 is specified on the command line, all 255 IP addresses are scanned. Now, why would we want to do this? As you know, if you are a privileged user, Nmap sends 4 types of packets to discover hosts: ICMP echo request, SYN packet to TCP 443 port, ACK packet to TCP 80 port, and ICMP timestamp request. If a system is configured not to answer to ICMP requests, and if the ports 80 and 443 are filtered, then Nmap thinks that the host is down even if it's up. If you find a system which is not found by ping scan, always use PN for further port scans. Otherwise, Nmap doesn't perform the port scan because it assumes that the host is not up. So if your network is not big, or if you don't have enough time to scan, you should skip the ping scan and run the port scans for every possible IP address. Use the port scan instead of ping scan if you are scanning a server block, because those systems are configured to be more secure than usual. Then you can find more computers than the ping scans do. You're halfway there. TCP scan, also known as TCP Connect scan, is the default TCP scan type when SynScan is not an option. Well, when is the SynScan not an option? Do you remember the trip of data packet on a DNS query? In that lecture, I said that Layer 3 and Layer 4 packets are managed by the operating system of your device. That means user does not interfere with a TCP three-way handshake. The whole process is managed by the operating system itself. In a SynScan, we interrupt the three-way handshake and don't send the last ACK packet to complete the handshake. You have to be a privileged user to be able to interrupt the handshake. If you're not a privileged user, you cannot interrupt three-way handshake and cannot perform a SYN scan as well. So instead of writing raw packets as most other scan types do, which needs admin privilege, Nmap asks the underlying operating system to establish a connection with a target machine and port by issuing the native connect system call. So you don't need to be a privileged user to perform TCP connect scans. When SYN scan is available, it is usually a better choice. Nmap has less control over the high-level connect call than with raw packets, making it less efficient. The system call completes connections to open target ports rather than performing the half-open reset that SYN scan does. Not only does this take longer and require more packets to obtain the same information, but target machines are more likely to log the connection, not too stealthy. The steps of TCP connect scan is exactly the same as TCP three-way handshake. You send a SYN packet to open a real connection and then wait for a response. A SYN-ACK response indicates the port is listening or open, while a RIST reset is indicative of a non-listener. If no response is received after several retransmissions or an ICMP unreachable error is received, the port is marked as filtered. If you receive a SYN-ACK from the target system, you send an ACK packet to complete the three-way handshake. Since we have nothing to say at the moment, we send RIST to end the conversation. Let's see what happens under the hood when we perform a TCP scan, and then compare the SYN scan with the TCP scan. Let's perform an Nmap TCP scan in our virtual network first. Go to Kali and open a terminal screen. I want to scan my Metasploitable system. So let's check if the host is up first. I know the IP address of my Metasploitable VM, so type ping 172.16.99.206 and hit enter. Okay, we received response packets. The system is up. Let's create the TCP scan command. Nmap is the command itself. S uppercase T is TCP scan. N is to avoid the DNS resolution. I'd like to see the IP addresses. Uppercase PN is to avoid the host discovery. I already know that the host is up, although you should make it a habit to use PN while you're scanning a single system. Now, we have the target IP address 172.16.99.206. And let's keep it fast. Scan for the top 10 ports only. I use top ports parameter for this purpose, and hit enter. Here are the states of the top 10 ports of Metasploitable. 7 ports are open and 3 ports are closed. Okay, let's open Wireshark and see what's happening when a TCP scan is performed. So you got to run Wireshark first. Double-click ETH0 to start to listen to that interface. To skip the packets which we're not interested in, I add a filter. I only want to see the traffic for my destination computer, 172.16.99.206. And I want to see the TCP traffic only. Click the blue arrow next to the filter bar to activate the filter. To clear the packets we've already caught, I restart Wireshark packet capturing. Okay, now go to the terminal screen. I'd like to analyze the TCP scan packets for an open port first. I'm going to run the latest Nmap query again, but this time, I run the query for port 80 only. Hit enter and run the Nmap query. Yes, the port is open as I remember. It's good to know I'm not losing my memory. Go back to Wireshark. I want to stop Wireshark by clicking the red square at the upper left corner to avoid unwanted packets. Now here we have 3 packets. The first packet is a SYN packet to start the three-way handshake. It's from an arbitrary port of Kali to the 80th port of Metasploitable, the destination system. Second packet is a SYN-ACK sent by the destination system. The third packet is an ACK sent by Kali to complete the TCP three-way handshake. And the fourth packet is a RIST sent by Kali again to end the conversation. Now this time, I want to scan a closed port, for example, port 81. Before running the query, I restart the Wireshark packet capturing to clean its screen by clicking the blue button in the upper left corner. In the terminal screen, I hit enter to run the query. As you see, port 81 is closed. Now let's look at the Wireshark interface to see what happened when we scan a closed port. The first packet is again a SYN packet to start the three-way handshake. The source system is Kali and the destination system is Metasploitable. The second packet is, for this scan, a RIST packet. Because port 81 is closed, the destination system sent us a RIST packet. So here we have a comparison between SYN scan packets and TCP scan packets for an open port. In SYN scan, Nmap has corrupted the three-way handshake by a RIST packet. In TCP scan, on the other hand, the three-way handshake is completed and the communication is established. So let's see the differences between the SYN scan and the TCP scan in a table that we've only really talked about up to now. Three-way handshake is not completed in SYN scan while it's completed in TCP scan. A RIST packet is sent when a SYN-ACK is received in SYN scan, while an ACK packet is sent in TCP scan. Target machines are more likely to log the connection when the connection is established in TCP scan. No log for SYN scans because three-way handshake is not established. Because the native operating system call is interrupted, SYN scan has to be run by a privileged user. TCP scan uses the system call, so it does not need extra privileges. UDP scan is activated with the S_U option. UDP scan works by sending a UDP packet to every targeted port. For some common ports such as 53 and 161, a protocol-specific payload is sent to increase response rate. But for most ports, the packet is empty. Well, there are some options to force Nmap to send non-empty packets such as data parameter. Because UDP scanning is generally slower and more difficult than TCP, some security auditors ignore these ports. Now, I think this is a mistake, as exploitable UDP services are quite common, and attackers certainly don't ignore the whole protocol. So in general, destination systems do not respond when they receive a UDP packet. So Nmap doesn't recognize if the port is open or filtered when there is no response from the target system. In this case, the port is flagged as open or filtered. To force the systems to respond to our packets, you'd be better off using UDP scan with version detection option. You'll have much more accurate results. Let's perform an Nmap UDP scan in our virtual network. Go to Kali and open a terminal screen. I want to scan my Metasploitable system. Let's create the UDP scan command. Nmap is the command itself. N is to avoid the DNS resolution. I like to see the IP addresses. Uppercase PN is to avoid the host discovery. We've seen these before. S_U is to do the UDP scan. Now here's the target IP address, 172.16.99.206. So let's keep it fast, scan for the top 10 ports only. I use top ports parameter for this purpose. Now, as I said a minute ago, UDP scan should run with version detection. Use S_V parameter to use the version detection. I'd like to add one more parameter here, which is reason. Reason parameter is used to show the reason why the state of the port is set as open, closed, or filtered. Now hit enter. See what I mean? UDP is much slower than SYN scan or TCP scan because the destination system does not respond in most of the time, and Nmap has to wait more to decide the states. And moreover, we use version detection, which sends more packets to understand the service and the version. So this scan takes much longer than the SYN or TCP scans. One IP address and 10 ports scanned in about, 100 seconds. Wake up if you took a nap. Here are the states of the top 10 UDP ports of Metasploitable. Ports 53 and 137 are flagged as open because they returned UDP responses. And you see the version of the services listening to those ports. Port 138 is flagged as open filtered because there is no response. And the other ports are flagged as closed because they returned ICMP port unreachable errors. Let's see how Nmap interprets the results of a UDP scan. Occasionally, a service will respond with a UDP packet, proving that it is open. If an ICMP port unreachable error, type 3, code 3, is returned, the port is closed. Other ICMP unreachable errors, type 3, codes 0, 1, 2, 9, 10, or 13, mark the port as filtered. If no response is received after retransmissions, the port is classified as open or filtered. Now is the time to find out the services which are listening to those ports and the version of those services. In addition, let's detect the operating systems running on those systems. Suppose that you ran an Nmap query and it told you that ports 25 TCP, 80 TCP, and 53 UDP are open. Using its Nmap services database of about 2,200 well-known services, Nmap would report that those ports probably correspond to a mail server, SMTP, web server, HTTP, and name server, DNS, respectively. This lookup is usually accurate. The vast majority of daemons listening on TCP port 25 are in fact mail servers. However, you should not bet your security on this. People can and do run services on strange ports. Even if Nmap is right, and the hypothetical server above is running SMTP, HTTP, and DNS servers, that is not a lot of information. When doing vulnerability assessments, or even simple network inventories of your companies or clients, you really want to know which mail and DNS servers and versions are running. Having an accurate version number helps dramatically in determining which exploits a server is vulnerable to. And version detection helps you obtain this information. After TCP and/or UDP ports are discovered using one of the other scan methods, version detection interrogates those ports to determine more about what is actually running. The Nmap Service Probes database contains probes for querying various services and match expressions to recognize and parse responses. Nmap tries to determine the service protocol, for example, FTP, SSH, Telnet, HTTP. The application name could be ISC bind, Apache HTTPD, Solaris Telnet-D. The version number, host name, device type, something like a printer or a router, and the OS family, you know what that is, Windows, Linux, etc. So let's see how to use service and version detection in Nmap and why it's important. Okay, go to Kali and open a new terminal window. Let's create the Nmap scan command. Nmap is the command itself. N is to avoid the DNS resolution. Uppercase PN is to avoid the host discovery. I'm using the SYNSCAN this time. I write the destination IP, which is the IP address of my Metasploitable VM, and the destination ports, the top 10 ports. Let's run this command first to see the results of a command without version detection. Now, I open a new terminal window to create a new Nmap command. I prepared the command with the same configuration. SYNSCAN, Metasploitable, and top 10 ports. I add S uppercase V parameter for version detection and hit Enter. As you see, the query takes longer this time. The SYNSCAN without the version detection took less than a second, and the SYNSCAN with version detection took about 12 seconds. In the first query, service names are estimated by Nmap according to the default services running on those ports. In the second query, on the other hand, Nmap probed the ports to determine more about what is actually running. Now, I want to show you the most important reason of using version detection in Nmap queries. In Kali, I'm going to run SSH on port 443 and then scan the port with Nmap. Let's perform the demo together. First, look at the listening services if SSH is running, netstat TNLP. SSH is running on port 22 at the moment. Type service SSH stop to stop SSH service and hit enter. Now, to change the port of SSH, we're going to change the configuration. Open the sshd_config file with a text editor to change it. I use Nano text editor for this purpose. Type nano/etc/ssh/sshd_config and hit enter. Find the port line, delete the sharp to make it a valid configuration line. The sharp was used to make it a comment line. Change the port number to 443. Control-X to exit Nano, Y to save changes, and hit enter to save over the existing file. Start SSH again using the service SSH start command. Look at the listening ports to double-check netstat TNLP. SSH service is running on port 443 now. Let's scan port 443 of Kali with Nmap. Prepare the Nmap synscan command. No version detection for this query. Nmap detects that the port is open. Look at the service. Nmap says the service is HTTPS. Using its Nmap services database, Nmap reported that this port probably corresponds to a web server for HTTPS, and we know that's not true. So let's prepare the Nmap synscan again, but this time use S_V parameter to run the version detection mechanism. Now, as you see, port 443 is running and the service is SSH, not HTTPS. Version detection interrogated the port to determine more about what is actually running. Nmap queried the port using the probes of the Nmap service probes database and matched expressions to recognize and parse responses. And the version of SSH is OpenSSH version 7.6p1. So, if you are not 100% sure about the type of the running service on a port, run version detection. Got it? Good. So one of Nmap's best-known features is remote OS detection using TCP/IP stack fingerprinting. Nmap sends a series of TCP and UDP packets to the remote host and examines practically every bit of the responses. After performing dozens of tests, such as TCP/ISN sampling, TCP option support and ordering, IP/ID sampling, and the initial window size check, Nmap compares the results to its Nmap OS/DB database of more than 2,600 known OS fingerprints and prints out the OS details if there's a match. Each fingerprint includes a free-form textual description of the OS and a classification which provides the vendor name, for example, Sun, underlying OS, that would be Solaris, OS generation, let's say 10, and device type, general purpose, router, switch, game console, whatever. OS detection is far more effective if at least one open and one closed TCP port are found. So let's see the OS detection in action. We have to use OS detection with one of the port detection techniques. So I use synscan for this demo. The target system is Metasploitable. Let's choose top 100 ports to make the query faster, or just don't give any port. Let the Nmap scan top 1,000 ports. That won't take long. Put uppercase O for OS detection and hit enter. Here is a result of OS detection. It's a general-purpose device and running Linux with a version between 2.6.9 and 2.6.33. If you would like Nmap to be more aggressive to have a more accurate result, you can use OSScan guess parameter with OS detection parameter. Now, let's scan a Windows system and try to find out the version of the OS. So here I have a Windows 8 virtual machine. I want to learn its IP address first. Open a command prompt, type ipconfig, and hit enter. Now let's go to Kali and test if we can reach the Windows system. First, I'll ping the system. No, the system is not responding to the ping requests, or we cannot reach the system. So second, I perform an Nmap ping scan. We know how to do it, right? Type Nmap SN 172.16.99.171 and hit enter. Yes, Nmap says the host is up. So we are able to reach the system. Now I want to scan the top 10 TCP ports of the system. I add the reason parameter to see the reasons of the results. All the ports we scanned are filtered because there are no responses from them. It's not good for us. So I add the OS detection to the latest Nmap query and rerun it. No, Nmap cannot find the OS details because it does not have a result set to probe or interrogate. I would like to open a port on the Windows system and reply the Nmap scans. In Windows 8 VM, I run the IIS, Internet Information Services Manager, and start to host the default website of IIS. Open a web browser and try to reach the website typing the IP address of the system into the address bar. Okay, web service is up. Let's test if I can reach the website from Kali. I go to Kali, open a browser, enter the IP address of the Windows 8 VM, and hit enter. No, I cannot, and I think I know the reason. In Windows VM, let's look at the firewall if HTTP traffic is allowed. So I open the firewall. At the upper left corner, I click Allow an app or feature through Windows Firewall link. Click Change Settings, which needs to have admin privileges. Go to the end of the list. As I thought, HTTP services are not allowed. Check it and click OK to apply the changes. Now in a command prompt to see port 80, I run netstat an command. When I come back to Kali, I see that the page is loaded in the browser. That means Kali can reach port 80 of my Windows 8 VM. Now in Terminal Screen, I want to run SynScan for the Windows system's top 10 ports. Here we have an open port now. So let's reply the scan with OS detection option. Now we have the OS detection result. First, Nmap warns us about the results. It says the results may be unreliable because it couldn't find a closed port to probe. But anyway, Nmap makes it best. And here it says the operating system is one of them. Windows 2008, Windows 8.1, Windows 7, Windows Phone, or Windows Vista. Good job. So a few lectures ago, we saw how we identify which ports are scanned. Now in Input Management, we'll see how we identify which systems are scanned. Okay, go to Kali and open a terminal window. First, I'll prepare an Nmap query, and because I'll play with the destination IPs, it will be the last parameter of my query. Nmap is the command itself. N to close the name resolution, uppercase PN to close ping, S uppercase S for SynScan. Now to keep it simple, let's scan just the top 3 ports. Now is the time to identify the destination systems. Up to now, we learned to scan a single IP, and we learned how to scan an entire C block, .0 through 24. Okay, so what are the other ways of identifying target systems? You can select a range of any part of the IP address. In the slide, the third and the fourth parts of the IP address is given as ranges. That means Nmap will scan IPs from 192.168.1.0 to 192.168.255.255. I'd like to keep the range small. I'll only define a range for the fourth part of the destination address from 100 to 150. There's only one machine between 172.16.99.100 and 172.16.99.150. You can scan more than one IP block in a single query. The example in the slide scans two ranges. The first range is between 192.168.1.0 and 192.168.1.255, and the second range is between 10.0.0.0 and 10.0.255.255. Since I don't have a second network on my Kali, I continue with the third example. The third example is the combination of defining a range and a single number. For example, you can scan the IPs between 100 and 140, IP 206, and the IPs between 220 and 230. So here are the results. Nmap found a machine from the range of 100 through 140, the machine with IP 206, and another machine from the range of 220 through 230. Another way to define the target systems is to give Nmap the IP addresses in a file. In a typical penetration test or ethical hacking, you will scan the network a lot of times. First, you find the hosts. It doesn't make sense to scan the entire network again and again. You'll see huge networks, so if you scan the entire network each time, the pen test will take a lot longer than you think. Let's open a second terminal screen and find the hosts of our IP block using PingScan. As we learned before, now clarify the output to have only the IP addresses of live hosts. grep command to get only the rows containing IP addresses, and cut command to get only the IP addresses from a row. Now we can redirect the output into a text file to reuse the list in following queries. But first, let me close the name resolution. Now, put a greater than character and give a file name to write the result, iplist.txt. We're not interested in the first two IP addresses, so let's edit the file and delete them. I use Nano Text Editor to edit the file. In Nano, use Ctrl-K to delete a line. Use Ctrl-X to exit Nano, press Y to save changes, and hit Enter to save on the same file. Type cat iplist.txt to look at the file again. Now we have 4 IP addresses in the file. Let's create a new Nmap query, and this time, let's give the destination systems in a file, iplist.txt. And here are the results of the 4 systems which are listed in the iplist.txt file. So let's talk about the output management in Nmap now. Up to now, we've run a lot of Nmap queries and got the results on the terminal screen. This is the default output behavior called interactive output, and it is sent to standard output, std out. In a penetration test, we should save the results of the queries to be able to analyze them later on. Hopefully, Nmap has its own output management skills. So let's have a look. There are 3 major output saving formats in Nmap. Normal output, which is similar to interactive output. That's what you see on the screen up to now, except that it displays less runtime information and warning, since it is expected to be analyzed after the scan completes rather than interactively. Grepable output, which includes most information for a target host on a single line, so you can use it to collect the information you want using the excellent grep command. We've already seen a few examples of grep command in this course. XML output is one of the most important output types, as it can be converted to HTML easily parsed by programs such as Nmap graphical user interfaces or imported into databases. There is one more magic parameter, which is O_A, to let you generate the outputs in all formats. Now let's see the Nmap output management in action. Go to Kali and open a terminal screen. Prepare an Nmap query. For this example, I want to prepare a SYN scan. Now we're ready for output management options. First, I want to generate the XML output using O_X parameter. O_X parameter needs the output file name. You can give the file name with the full path. If you don't specify a path, just as in this example, the file is created in the current folder. Be careful, OX, OG, and ON parameters require the full file name. So if you want the file to have an extension such as .xml, you should specify it here. Hit Enter to run the command. To see the generated file, here it is. And use the less command to see the content of the file. So it's typical XML file with tags. Here's a host tag, starts and ends. All the results about a host is listed between the start tag and the end tag. IP address, scan ports, and of course, the scan results. Here is another host tag and the scan results of the second host as well. Press Q to quit, less command. Now let's call back our Nmap query with the up-down arrow keys of the keyboard. Now I want to generate all types of outputs. Type O_A and the base name of the files. Be careful, O_A parameter requires the base file name of the files, not the full names of the files, and it'll put the file extensions itself. Let's look at the content of .nmap file using the less Linux command. This is almost the same as you'll see on the screen. Now let's look at the greppable output. Here there are 2 lines for each host. One to show the status of the host, and another one to show the port scan results. All right, so EtterCap is a collection of tools that can be used for a variety of tasks. Its main function, though, is to reroute network traffic through its host computer while sniffing the traffic. So it has a software stack required to do both. EtterCap is a sniffing program similar to DSniff in that it can sniff traffic and look for specific credentials for certain protocols. For example, email passwords or whatever you want. Now, it also offers the ability to change traffic or filter traffic, so you can drop packets depending on a specified filter criteria. But it's also a free and open source network security tool for man-in-the-middle attacks on LAN. As a man-in-the-middle attack tool, EtterCap has a capability to run ARP, ICMP, DNP spoofing attacks. EtterCap has both a command line interface version and a graphical user interface version. So I want to show you what they look like in action. Now, just so you know, EtterCap no longer comes pre-installed in Kali Linux. So first of all, we'll need to install EtterCap. Just open the terminal, write EtterCap. And as you can see, the terminal actually shows us how we can install the graphical and command line interface version of EtterCap. And you can download the graphical version. You can download the CLI version. It's up to you. But when you download it, we can use EtterCap with an interface or by using the command line. So write sudo apt install ettercap-graphical. And of course, it may take some time. So write EtterCap. And as you can see, EtterCap is ready to run. Okay, so let's just do a simple ARP spoof attack. Now you can see my machine's IP addresses in my network at the top right corner. I have a Kali, an OWASP BWA, and a Metasploitable VM in the network. So use ifconfig inside the VMs to check the IP addresses and the other interface configurations as well. So ping each other to be sure that they can communicate. Okay? Now I go to Kali, open a terminal screen, and do the same here. Check the interface configuration and ping other VMs. everything's okay. So let's look at the ARP table of Metasploitable. Type ARP-N and press enter. So currently there are 2 records in the ARP table of Metasploitable, one for Kali and one for OWASP BWA. Now let me show you something. If you want to perform an ARP spoof attack, you should enable IP forwarding in your attacker system so that the packets will not end on your attacker system and be forwarded to the destination system. Otherwise, you'll block the traffic between the victim and the spoofed system. Check that out. So the IP address is managed by a variable IP forward, like in Kali. And to look at the file content, type cat/proc/sys/net/IPv4/IP forward and press enter. Its value is 0. So to enable it, it has to be 1. So I'll change it. You can open the file with a text editor and change the value, but here I'll just simply use the echo command for this purpose. Echo 1 greater than sign the entire file name. So check the file again. And yes, its value is now 1. Now, please note that EtherCap enables IP forwarding automatically, even though you don't enable it manually. All right, I want you to know what's happening behind the scenes, so to speak. All right, so now's the time of the attack. Before creating the command, let's see the manual of EtherCap. So type man EtherCap and press enter. So here's the short definition and the long description. Targets, options, M for man in the middle, MIT-M attack. So these are the MIT-M attack types. ARP is at the first line, and the others, ICMP, DHCP, etc. And here are the user interface options. T for the text-only interface. Anyway, let's just create the command. So first, the command itself, EtherCap. I, the interface, either 0. T for the text-only interface type. M to make it a MIT-M attack. And select the MIT-M attack type, ARP, column, remote. So the first IP specifies the IP address which will be spoofed. And the second IP address is the victim system. So that means there will be a row in the Metasploitable's ARP table with a Kali's MAC address and OWASP BWA's IP address. And that means when Metasploitable wants to send a packet to OWASP BWA, it will be sent to Kali instead, right? And with the help of IP forwarding, the packet will arrive at OWASP BWA finally. Now, please don't forget to use these slashes at the beginning and end of each IP address. The command is ready to run. So let's see what it does. Hit enter. And here's a summary of the attack, the victims, interface type, etc. Now I'll go to Metasploitable, ARP-N, to see the ARP table again. And as you can see here, the first record is for Kali. So please look at the MAC address. And the second record is for OWASP BWA, but with the attacker's MAC address. Any packet sent from Metasploitable to OWASP BWA will visit Kali now. Now you might remember what I told you before that, well, I hope you remember everything that I told you before. But in particular, EtherCap has a graphical user interface as well. So let's have a look at EtherCap's GUI right now. Again, we're in Kali. Click Show Applications menu item and type EtherCap. And here you go, you'll find the EtherCap GUI app. So these are both EtherCap GUI apps. You can just simply click one of them.
So here is a sniffing interface. You can change the primary interface here, and right up here, the right top corner, you can start sniffing. Now, as you can see above, unified sniffing has started. And at the top left corner, you can stop the sniffing scan for the host. Now, it's a kind of a ping scan to find out the devices of the network. So it's found 5 devices and added them to the hosts list. So now select hosts list, and here's a list. All right, so that's very nice. Now in the top right corner, you can see the man-in-the-middle attack menu. You can choose your attack type and start an attack from here. You can stop the man-in-the-middle attack from here as well. From here, you can also see whole menus, targets, hosts, view, filter, logging, plugins. All right, so let's do up an example. ARP spoofing. Stop sniffing. 10.0.2.4 is OWASP BWA. So this is the system that will spoof. So select it and click Add to Target 2. 10.0.2.5 is Metasploitable. That's our victim. So we'll change its ARP table. Select it and click Add to Target 1. I think now we're ready to attack. What do you think? All right, so let's go to MIT-M and click ARP Poisoning. Okay, check the Sniff Remote Connections option and click OK. And the final step, go to Start and select Start Sniffing. So the attack has begun. Let's go to Metasploitable and see the attack result. To see the ARP table, type ARP-N and press Enter. The first row is for OWASP BWA, but the MAC address is Kali's MAC. To show it, now I'll ping Kali to create the ARP record. Run the ARP command again, and now I have another row for Kali. And both Kali and OWASP BWA have the same MAC address. Okay, you know the rest. The packets will be sent to Kali instead of OWASP BWA. So if you'd like, you can open Wireshark and collect the fruits of your labor. Enjoy it. Because it's one of the most powerful exploit frameworks, and it has a free version with a wide functionality, we're going to use Metasploit throughout the course. Metasploit Project is the most used penetration testing framework in the world. It can be used to test the vulnerability of computer systems or to break into remote systems. As I mentioned before, Metasploit was created by H.D. Moore in 2003 using Perl. By 2007, the Metasploit framework had been completely rewritten in Ruby. In 2009, the project was acquired by Rapid7. Now they have a free and open source version, Metasploit Framework, and a commercial version, Metasploit Pro. Its best-known subproject is the open source Metasploit Framework, a tool for developing and executing exploit code against a remote target machine. The MSF console is probably the most popular interface to the Metasploit Framework, MSF. It provides an all-in-one centralized console and allows you efficient access to virtually all of the options available in MSF. MSF console may seem intimidating at first, but once you learn the syntax of the commands, you'll learn to appreciate the power of utilizing this interface. You with me? Good. Everything is okay, so let's start getting our hands dirty. Now, because Metasploit Framework is embedded in Kali, you can type MSF console in any location in the terminal screen to start Metasploit Framework console interface. You'll be facing the shell-like MSF interface in just a few seconds. And here we have a summary. Numbers of exploits, auxiliaries, and post modules, and numbers of payloads, encoders, and NOPs. The first command that you should learn in MSF console is, of course, help. The help command lists all the commands you can use at this point. And you heard me correctly, I do say at this point, because any module you load may add some new commands you can use. But we'll see soon, and I'll let it go for now. As you can see,
the commands are grouped. Here are the core commands, module commands, job commands, resource script commands, and credential backend commands. Now, to search for a module you want to use, for example, to see the available exploits developed to exploit Net API vulnerabilities, you can simply use the search command with a keyword. And here are the results. Exploits for several Net API vulnerabilities. The first one is to exploit the MS03-049 vulnerability, and we have 4 exploits for 4 different Net API vulnerabilities. Now, you can see the columns, name of the module, disclosure date, rank, and description of the module. Since the names of the other columns explain themselves, let's talk about the ranks. In Metasploit framework, the exploits are ranked to help us select the appropriate exploit. Here are all the ranks and their meanings. Starting off with excellent. The exploit will never crash the service. This is the case for SQL injection, CMD execution, RFI, LFI, etc. No typical memory corruption exploit should be given this ranking unless there are extraordinary circumstances. Great. The exploit has a default target and either auto-detects the appropriate target or uses an application-specific return address after a version check. So good is that the exploit has a default target and it is the common case for this type of software. English, Windows 7 for desktop app, 2012 for server, etc. So normal, this exploit is otherwise reliable, but depends on a specific version and can't or doesn't reliably auto-detect. Average, the exploit is generally unreliable or difficult to exploit. And low, the exploit is nearly impossible to exploit, or under 50% success rate for common platforms. And manual, the exploit is unstable or difficult to exploit and is basically a DOS. This ranking is also used when the module has no use unless specifically configured by the user. For example, exploit/unix/webapp/php eval. Now, I promised to get your hands dirty, and I don't want to bore you with too much theory, so let's compromise some systems. We performed a vulnerability scanning, and you'll certainly remember that there was an exploitable vulnerability in the Java RMI service of the Metasploitable system. So let's exploit the Metasploitable. Here we are in the MSF console, so you can use the search command to find the exploits for Java RMI server insecure default config vulnerability. Here we find 2 auxiliaries and 2 exploits. To use the exploit, we use the use command of MSF console. Give the full name of the exploit you see. And you see the command prompt shows us which exploit or auxiliary that we are using. Now we can select a payload, type show payloads to see the payloads available with this exploit. You're going to see different payload lists for different exploits, but we have to choose one of these payloads. But you know something? I'd like to pause here for a bit for a little bit of definition. Sorry for that. I know you're chomping at the bit, but I'd like you to understand what it is that you're actually doing. So there are 3 different types of payload modules in the Metasploit framework: singles, stagers, and stages. These different types allow for a great deal of versatility and can be useful across numerous types of scenarios. Whether or not a payload is staged is represented by / in the payload name. For example, Windows/shell bind TCP is a single payload with no stage, whereas Windows/shell/reverse TCP RC4 consists of a stager reverse TCP RC4, and a stage shell. So singles are payloads that are self-contained and completely standalone. A single payload can be something as simple as adding a user to the target system or running calc.exe. These kinds of payloads are self-contained, so they can be caught with non-Metasploit handlers such as Netcat. Stagers set up a network connection between the attacker and victim and are designed to be small and reliable. It is difficult to always do both of these well, so the result is multiple similar stagers. Metasploit will use the best one when it can and fall back to a less preferred one if it's necessary. Stages are payload components that are downloaded by stagers modules. The various payload stages provide advanced features with no size limits such as Meterpreter, VNC injection, and the iPhone iPwn shell. Okay, so where were we? Right. We were about to set the payload for our exploit. To use the payload we want, we use the set payload Metasploit command. And look at that, you'll see that there are two popular types of shells, bind and reverse. A bind shell is the kind that opens up a new service on the target machine and requires the attacker to connect to it in order to get a session. A reverse shell, it's also known as a connect-back, is the exact opposite. It requires the attacker to set up a listener first on his box. The target machine acts as a client connecting to that listener, and then, finally, the attacker receives the shell. So here I want to use the Java/shell/reverse TCP payload for this example. Type show options to see the parameters we have to configure. Now these are the parameters of the module, and these are the parameters of the selected payload. Required field shows if you have to fill in the parameter or not. If the option is required, it cannot be empty. So let's set the options for this exploit. Module options first. The first option is HTTP delay, which indicates the time that the HTTP server will wait for the payload request. It has a default value, 10. Just leave it as it is. rhost is the remote host, which means the target machine. In this example, Metasploitable, set rhost with the IP address of Metasploitable. rport is the target port. As we've seen before, Java RMI service port of Metasploitable is 1099, which is the default value of the option. Serve host is another required field, which stands for the local host to listen on. Kali for us. So set serve host with the IP address of Kali. Serve post is another required field, the local port to listen on. And that has a default value of 8080. No need to change the default here. So the last three options are not required, so I'll just let them be with the default values. Now, let's set the payload options. Because it's a reverse shell payload, it asks the listener host's IP address and the port. Both of them are, of course, required. So set the lhost, the listener address, as your Kali. And if you'd like, change the default value of the listen port. 4444 is fine for me. Now we are ready to run the exploit. And here you can use either run or the exploit command to run the exploit. Okay, so what the heck happened here? Let's look at the messages given by Metasploit. This module takes advantage of the default configuration of the RMI registry and RMI activation services, which allow loading classes from any remote HTTP URL. Here, it tries to exploit the vulnerability which is on the service running on the port 1099 of Metasploitable, using the application running on the port 8080 of our Kali. And finally, it says a command shell session opened, which means exploitation is successful. Now, because we don't need the HTTP server opened in Kali anymore, it's stopped at the end of the exploitation. Sessions command is used to see the session running in the background. We'll see the session command in details. type session L to see the active sessions and sessions I1 to interact with the session which has the ID number 1. I think the interaction has started, so let's try it. I'll send the ls command, and yes, we now have the shell for Metasploitable. Print working directory, we are at the root. Who am I? We are the root user, if config to learn the IP address, etc.
In today's lesson, we will start with an introduction to Metasploit and a walkthrough of its usage on the TryHackMe platform. Metasploit is a powerful penetration testing framework that allows security professionals to identify and exploit vulnerabilities in target systems. It provides a wide range of tools and features for conducting penetration tests, including exploit development, payload generation, and post-exploitation modules. On the TryHackMe platform, you can practice using Metasploit in a safe and controlled environment. By completing various challenges and rooms, you'll learn how to use Metasploit to exploit vulnerabilities, gain unauthorized access to systems, and escalate privileges. Throughout this lesson, we will explore the basics of Metasploit, including its architecture, common commands, and practical usage scenarios. By the end of the session, you'll have a better understanding of how Metasploit works and how it can be leveraged for ethical hacking and penetration testing purposes. Let's dive into the world of Metasploit and start our journey to mastering this powerful tool. Task 1. Metasploit is the most widely used exploitation framework. Metasploit is a powerful tool that can support all phases of a penetration testing engagement, from information gathering to post-exploitation. Metasploit has two main versions. Metasploit Pro, the commercial version that facilitates the automation and management of tasks. This version has a graphical user interface GUI. Metasploit Framework, the open-source version that works from the command line. This room will focus on this version, installed on the attack box and most commonly used penetration testing Linux distributions. The Metasploit framework is a set of tools that allow information gathering, scanning, exploitation, exploit development, post-exploitation, and more. While the primary usage of the Metasploit framework focuses on the penetration testing domain, it is also useful for vulnerability research and exploit development. The main components of the Metasploit framework can be summarized as follows. MSF console, the main command line interface. Modules, supporting modules such as exploits, scanners, payloads, etc. Tools, standalone tools that will help vulnerability research, vulnerability assessment, or penetration testing. Some of these tools are MSF Venom, Pattern Create, and Pattern Offset. We will cover MSF Venom within this module, but Pattern Create and Pattern Offset are tools useful in exploit development, which is beyond the scope of this module. This room will cover the main components of Metasploit while providing you with a solid foundation on how to find relevant exploits, set parameters, and exploit vulnerable services on the target system. Once you have completed this room, you will be able to navigate and use the Metasploit command line comfortably. You can deploy and use the attack box to complete tasks and answer the questions, but I will use attack box. You can choose any of it. Task 2. While using the Metasploit framework, you will primarily interact with the Metasploit console. You can launch it from the attack box terminal using the MSF console command. The console will be your main interface to interact with the different modules of the Metasploit framework. Modules are small components within the Metasploit framework that are built to perform a specific task, such as exploiting a vulnerability, scanning a target, or performing a brute force attack. Before diving into modules, it would be helpful to clarify a few recurring concepts: vulnerability, exploit, and payload. Exploit, a piece of code that uses a vulnerability present on the target system. Vulnerability, a design, coding, or logic flaw affecting the target system. The exploitation of a vulnerability can result in disclosing confidential information or allowing the attacker to execute code on the target system. Payload. An exploit will take advantage of a vulnerability. However, if we want the exploit to have the result we want, gaining access to the target system, read confidential information, etc., we need to use a payload. Payloads are the code that will run on the target system. Modules and categories under each one are listed below. These are given for reference purposes, but you will interact with them through the Metasploit console, MSF console. Auxiliary. Any supporting module, such as scanners, crawlers, and fuzzers, can be found here. Encoders. Encoders will allow you to encode the exploit and payload in the hope that a signature-based antivirus solution may miss them. Signature-based antivirus and security solutions have a database of known threats. They detect threats by comparing suspicious files to this database and raise an alert if there is a match. Thus, encoders can have a limited success rate as antivirus solutions can perform additional checks. Evasion. While encoders will encode the payload, they should not be considered a direct attempt to evade antivirus software. On the other hand, evasion modules will try that with more or less success. Exploits. Exploits neatly organized by target system. Nopes. Nopes, no operation, do nothing, literally. They are represented in the Intel x86 CPU family with 0x90, following which the CPU will do nothing for one cycle. They are often used as a buffer to achieve consistent payload sizes. Payloads. Payloads are codes that will run on the target system. Exploits will leverage a vulnerability on the target system, but to achieve the desired result, we will need a payload. Examples could be getting a shell, loading a malware or backdoor to the target system, running a command, or launching calc.exe as a proof of concept to add to the penetration test report. Starting the calculator on the target system remotely by launching the calc.exe application is a benign way to show that we can run commands on the target system. Running command on the target system is already an important step, but having an interactive connection that allows you to type commands that will be executed on the target system is better. Such an interactive command line is called a shell. Metasploit offers the ability to send different payloads that can open shells on the target system. You will see 4 different directories under payloads: adapters, singles, stagers, and stages. Adapters. An adapter wraps single payloads to convert them into different formats. For example, a normal single payload can be wrapped inside a PowerShell adapter, which will make a single PowerShell command that will execute the payload. Singles. Self-contained payloads add user, launch notepad.exe, etc. that do not need to download an additional component to run. Stagers. Responsible for setting up a connection channel between Metasploit and the target system. Useful when working with staged payloads. Staged payloads will first upload a stager on the target system, then download the rest of the payload stage. This provides some advantages as the initial size of the payload will be relatively small compared to the full payload sent at once. Stages. Downloaded by the stager. This will allow you to use larger size payloads. Metasploit has a subtle way to help you identify single, also called inline payloads, and staged payloads. Generic shell reverse TCP. Windows x64 shell reverse TCP. Both are reverse Windows shells. The former is an inline or single payload, as indicated by the underscore between shell and reverse, while the latter is a staged payload, as indicated by the slash between shell and reverse. Post. Post modules will be useful on the final stage of the penetration testing process listed above, post-exploitation. If you wish to familiarize yourself further with these modules, you can find them under the modules folder of your Metasploit installation. For the attack box, these are under opt Metasploit framework embedded framework modules. Task 3. As previously mentioned, the console will be your main interface to the Metasploit framework. You can launch it using the MSF console command on your attack box terminal or any system the Metasploit framework is installed on. Once launched, you will see the command line changes to MSF6 or MSF5 depending on the installed version of Metasploit. The Metasploit console MSF console can be used just like a regular command line shell, as you can see below. The first command is ls, which lists the contents of the folder from which Metasploit was launched using the ms console command. It is followed by a ping sent to Google's DNS IP address, 8.8. As we operate from the attack box, which is Linux, we had to add the C1 option, so only a single ping was sent. Otherwise, the ping process would continue until it is stopped using CTRL+C. It will support most Linux commands, including clear, to clear the terminal screen, but will not allow you to use some features of a regular command line, e.g. does not support output redirection, as seen below. While on the subject, the help command can be used on its own or for a specific command. Below is the help menu for the set command we will cover soon. You can use the history command to see commands you have typed earlier. An important feature of MSF console is the support of tab completion. This will come in handy later when using Metasploit commands or dealing with modules. For example, if you start typing he and press the tab key, you will see it auto-completes to help. MSF console is managed by context. This means that, unless set as a global variable, all parameter settings will be lost if you change the module you have decided to use. In the example below, we have used the MS17010 Eternal Blue exploit, and we have set parameters such as roasts. If we were to switch to another module, e.g. a port scanner, we would need to set the roasts value again, as all changes we have made remained in the context of the MS17010 Eternal Blue exploit. Let us look at the example below to have a better understanding of this feature. We will use the MS17010 Eternal Blue exploit for illustration purposes. Once you type the use exploit Windows SMB MS17010 Eternal Blue command, you will see the command line prompt change from MSF6 to MSF6, exploit Windows SMB MS17010 Eternal Blue. The Eternal Blue is an exploit allegedly developed by the U.S. National Security Agency NSA for a vulnerability affecting the SMB v1 server on numerous Windows systems. The SMB server message block is widely used in Windows networks for file sharing and even for sending files to printers. Eternal Blue was leaked by the cybercriminal group Shadow Brokers in April 2017. In May 2017, this vulnerability was exploited worldwide in the WannaCry ransomware attack. The module to be used can also be selected with the use command followed by the number at the beginning of the search result line. While the prompt is changed, you will notice we can still run the commands previously mentioned. This means we did not enter a folder, as you would typically expect in an operating system command line. The prompt tells us we now have a context set in which we will work. You can see this by typing the show options command. This will print options related to the exploit we have chosen earlier. The show options command will have different outputs depending on the context it is used in. The example above shows that this exploit will require we set variables like roasts and rport. On the other hand, a post-exploitation module may only need us to set a session ID. See the screenshot below. A session is an existing connection to the target system that the post-exploitation module will use. The show command can be used in any context followed by a module type, auxiliary, payload, exploit, etc. To list available modules, the example below lists payloads that can be used with the MS17010 Eternal Blue exploit. If used from the MSF console prompt, the show command will list all modules. The use and show options commands we have seen so far are identical for all modules in Metasploit. You can leave the context using the back command. Further information on any module can be obtained by typing the info command within its context. Alternatively, you can use the info command followed by the module's path from the MSF console prompt, e.g. One of the most useful commands in MSF console is search. This command will search the Metasploit framework database for modules relevant to the given search parameter. You can conduct searches using CVE numbers, exploit names, Eternal Blue, Heartbleed, etc. or target system. The output of the search command provides an overview of each return module. You may notice the name column already gives more information than just the module name. You can see the type of module, auxiliary, exploit, etc., and the category of the module, scanner, admin, Windows, Unix, etc. You can use any module returned in a search result with the command use followed by the number at the beginning of the result line, e.g. use 0, instead of use auxiliary admin smbms17010 command. Another essential piece of information returned is in the rank column. Exploits are rated based on their reliability. The table below provides their respective descriptions. You can direct the search function using keywords such as type and platform. For example, if we wanted our search results to only include auxiliary modules, we could set the type to auxiliary. The screenshot below shows the output of the search type auxiliary telnet command. Task 4. You can launch the target machine attached to this room to replicate the examples shown below. Any Metasploit version 5 or 6 will have menus and screens similar to those shown here, so you can use the attack box or any operating system installed on your local computer. Once you have entered the context of a module using the use command followed by the module name, as seen earlier, you will need to set parameters. The most common parameters you will use are listed below. Remember, based on the module you use, additional or different parameters may need to be set. It is good practice to use the show options command to list the required parameters. All parameters are set using the same command syntax. Set parameter name value. Before we proceed, remember always to check the MSF console prompt to ensure you are in the right context. When dealing with Metasploit, you may see 5 different prompts. The regular command prompt, you cannot use Metasploit commands here. The MSF console prompt, MSF6 or MSF5, depending on your installed version, is the MSF console prompt. As you can see, no context is set here, so context-specific commands to set parameters and run modules cannot be used here. A context prompt. Once you have decided to use a module and use the set command to choose it, the MSF console will show the context. You can use context-specific commands here. The Meterpreter prompt. Meterpreter is an important payload we will see in detail later in this module. This means a Meterpreter agent was loaded to the target system and connected back to you. You can use meterpreter-specific commands here. A shell on the target system. Once the exploit is completed, you may have access to a command shell on the target system. This is a regular command line, and all commands typed here run on the target system. As mentioned earlier, the show options command will list all available parameters. As you can see in the screenshot above, some of these parameters require a value for the exploit to work. Some required parameter values will be pre-populated. Make sure you check if these should remain the same for your target. For example, a web exploit could have an R port, remote port. The port on the target system Metasploit will try to connect to and run the exploit, value preset to 80, but your target web application could be using port 8080. In this example, we will set the ROS parameter to the IP address of our target system using the set command. Once you have set a parameter, you can use the show options command to check the value was set correctly. Parameters you will often use are ROS remote host, the IP address of the target system. A single IP address or a network range can be set. This will support the CIDR classless interdomain routing, notation, or a network range. You can also use a file where targets are listed, one target per line using that. R port, remote port. The port on the target system the vulnerable application is running on. The payload you will use with the exploit. L host, localhost, the attacking machine your attack box or Kali Linux IP address. L port, local port, the port you will use for the reverse shell to connect back to. This is a port on your attacking machine, and you can set it to any port not used by any other application. Session. Each connection established to the target system using Metasploit will have a session ID. You will use this with post-exploitation modules that will connect to the target system using an existing connection. You can override any set parameter using the set command again with a different value. You can also clear any parameter value using the unset command or clear all set parameters with the unset all command. You can use the setgg command to set values that will be used for all modules. The setgg command is used like the set command. The difference is that if you use the set command to set a value using a module and you switch to another module, you will need to set the value again. The setgg command allows you to set the value so it can be used by default across different modules. You can clear any value set with setg using unsetg. The example below uses the following flow. We use the MS17010 Eternal Blue exploitable. We set the ROS variable using the setg command instead of the set command. We use the back command to leave the exploit context. We use an auxiliary. This module is a scanner to discover MS17010 vulnerabilities. The show options command shows the ROS parameter is already populated with the IP address of the target system. The setg command sets a global value that will be used until you exit Metasploit or clear it using the unsetg command. Using modules. Once all module parameters are set, you can launch the module using the exploit command. Metasploit also supports the run command, which is an alias created for the exploit command. As the word exploit did not make sense when using modules that were not exploits, port scanners, vulnerability scanners, etc. The exploit command can be used without any parameters or using the Z parameter. The exploit Z command will run the exploit and background the session as soon as it opens. This will return you the context prompt from which you have run the exploit. Some modules support the check option. This will check if the target system is vulnerable without exploiting it. Sessions. Once a vulnerability has been successfully exploited, a session will be created. This is the communication channel established between the target system and Metasploit. You can use the background command to background the session prompt and go back to the MSF console prompt. Alternatively, CTRL+Z can be used to background sessions. The sessions command can be used from the MSF console prompt or any context to see the existing sessions. To interact with any session, you can use the sessions I command followed by the desired session number. Task 5. As we have seen so far, Metasploit is a powerful tool that facilitates the exploitation process. The exploitation process comprises three main steps: finding the exploit, customizing the exploit, and exploiting the vulnerable service. Metasploit provides many modules that you can use for each step of the exploitation process. Through this room, we have seen the basic components of Metasploit and their respective use. It would be best if you also had used the MS17010 Eternal Blue exploit to gain access to the target VM. In the following rooms, we will cover Metasploit and its components in more detail. Once completed, this module should give you a good understanding of the capabilities of Metasploit.
Hydra is a free and open source command line tool to crack valid login password pairs online. It's very fast and flexible, and new modules are easy to add. Hydra is embedded in Kali. But before using it, we'd better see some of its parameters. You can specify the username list, let's say the user directory, with uppercase L parameter. If you'd like to find the password of a valid user, you can specify a single user with lowercase l parameter instead. You can also specify the password list. Let's call it the password dictionary with uppercase P parameter. If you find a password, for example, while dumpster diving and don't know the user, you can specify a single password with lowercase p. If one valid username password pair is enough for us, we can use the F parameter, and that makes a tool exit when it finds a valid username password pair. Server is another required parameter of the tool, which stands for the target server. And finally, we have to specify the service that we want to attack. Some supported services are HTTP post form, HTTPS post form, HTTP get form, HTTPS get form, HTTP proxy, MS SQL, MySQL, Oracle Listener, SSH, Cisco, etc. Every protocol has its own unique options to set. We'll see the options for HTTP post form in the following demonstration. So now I'll go to Kali and run a web browser. Do you remember OWASP Broken Web Applications, abbreviated BWA server? Well, it's on my network with the IP number of 139. Write in the IP address in the address bar of the browser and hit enter. Now, here's the home page of the OWASP BWA. I'll scroll down a bit and click Damn Vulnerable Web Application link. Now, we arrived at a login page that asks for the username and the password. Now, we don't know any credential, and we'll try to find a valid username password pair by online password cracking attack. So open a terminal screen. Hydra is embedded in Kali, so you can start to use it simply by typing its name. If you type Hydra with no parameter, the help page appears. Here is the list of options and supported services. So let's start to build our attack. L is the first parameter. To keep the attack simple and fast, I suppose that we'll know a valid user, which is going to probably be admin, so I'll use the lowercase l parameter. Now we specify the password dictionary with uppercase P. Well, there are some dictionaries in Kali. Let me find them, and I'll use one. So I open a new terminal screen and search for the dictionaries using the find Linux command. So I'm looking for the files that start with pass and have .lst extension. I found a few, so let's look at the contents of one of them using the less Linux command. You can search a phrase with / indicator within the less command. So I look for admin if the word exists in the dictionary. Well, because I know the password of the admin user is admin, and I want to show you a successful attack, Okay, now this is the target server, OWASP BWA139. I have to specify the service we attack. So to learn the service, let's go to the browser again. But before trying to log in, I run Burp Suite. Now, I think I should tell you a little bit about Burp Suite. Burp Suite is used in web application penetration tests, and I've explained and used it extensively in hacking web applications and penetration testing. That's the course that fully lays it out in detail. But I'll just give you a little introduction to it now if you haven't done that course. Burp Suite is a web application penetration testing framework. It has become an industry standard suite of tools used by information security professionals to identify vulnerabilities and verify attack vectors for web-based applications. I suppose in its simplest form, Burp Suite can be classified as a personal proxy or interception proxy. A penetration tester configures their internet browser to route traffic through the proxy, which then acts as a sort of man in the middle by capturing and analyzing each request and response to and from the target web app. Individual HTTP requests can be paused, manipulated, and replayed back to the web server for targeted analysis of parameter-specific injection points. The injection points can be then specified for manual as well as automated fuzzing attacks to discover potentially unintended application behaviors, crashes, and error messages. You got all that? So now we can continue to the online cracking session with Hydra. Burp Suite is started. We have to route traffic through Burp Suite to be able to listen to the requests and responses and analyze them. So to do this, we should change the proxy settings of the browser to listen to the port 8080 of the local host. You can change the proxy of the browser from the Preferences menu. I just use Foxy Proxy. It's a plugin to change the proxy of the browser easily. This little fox icon is Foxy Proxy. I'll click on it. And here there's proxy settings for the port 8080 of the local host. Now, you can use the proxy from your browser's network setting, as seen in the picture here. So I'll choose the proxy localhost 8080, and now my browser's traffic is routed through the Burp Suite. So now I'll make a login attempt. So Burp intercepted the login request. It's a post, so we find the service to attack. Back to the Hydra query, the next parameter is HTTP post form. Now is the most critical part of building a Hydra attack, setting the options of the service. There are three parts of the options of the service HTTP post form separated by the colon character. The first part is the address of the authentication form. The second part is the form parameters, and here they are. I'll copy them and paste them as the second part of the service options. Now, this is an important point again. The place that the passwords will be set for online cracking attacks are labeled as pass between two caret signs. Same as a password field. The place of the username is signed as user between two caret characters as well. The third part of the service option is a unique part from the response message of a failed login attempt. So I go to the browser, copy the login failed message, and paste that as a third part of the option. I think the service options are ready. So at last, I put a F parameter to make the tool exit when it finds a valid credential. So we're ready to run the command now. Just hit enter and online password cracking attack starts. Now we'll wait as much as it takes. It reports every minute. And this is the first minute's report. 933 tries per minute. That's pretty good. And it says it has 2,626 tries to do. Now here it found a valid username-password pair just after the second minute's report. The username was already fixed, admin, and it found that the password is admin for the user. And since we used the F parameter, it stopped working as soon as it found a valid credential. Now we can go to the app and enter admin for the username and again admin for the password to log in. So let's see how we can perform a dictionary attack on SSH service using Hydra. So we'll want to open a terminal screen in Kali. Now I want to test a network connection first between Kali and the target system, which is 192.168.10.11 for me at the moment. Now I want to learn whether the SSH service is running on the target. And to achieve this, I'm going to use the Nmap tool. I know you're already a step ahead of me. That's good. The first parameter is the IP address of the target machine. So let's scan the most common 100 ports, which will cover the default SSH port, which is 22. Now the last parameter is to detect the versions of the services. If you don't use version detection, Nmap labels the ports according to the default services. For example, if SSH is running on, let's say, port 80, and you don't use the version detection option, Nmap labels the service as HTTP, which is not correct. So now we've got the results in 12 seconds. And as you'll see, the SSH service is running on port 22. Next up is try to establish an SSH connection to the target. Well, I'm feeling pretty lucky today, and I want to try for the root user first. So, type SSH root at the target IP and hit enter. It's asking for the password, so we can suppose that the target system is open to connect with the root user. We don't know the password as of yet, so I'll just press Control and C to cancel the login period. Okay, now is the time to use Hydra to perform a password cracking attack onto that target machine. So if you type Hydra and press Enter, the help page appears. Explanation, what Hydra is, and here are the options. Now, these are the supported devices, including the SSH service. So, let's go ahead and build the command together. Since we know the root user is enabled for the SSH service of the target machine, we can give a single user, root, as the username with lowercase l as the parameter. The uppercase P is to define the dictionary, which will be used in the attack. Well, we're going to need a dictionary, so let's search Kali to find one. I'll just use the find Linux command for this purpose. The first parameter is where it's going to start to search. Slash means that it will start searching from the root folder. Name means that we want to find the files according to their file names. Now, I want to find the files where the name starts with password. Star here represents that the rest of the name might be, well, anything. So it's okay to hit enter. Well, now, there are a lot of files. I did not expect that, did you? So let's scroll up a bit. Okay, here. I found a folder with the name word lists. So let's go to the folder and look at those word lists. ls to list the files. Well, look at that. There are a lot of word lists for different purposes. Here there's a word list, Unix passwords. That's not a big file, in fact, but I don't want to waste time while waiting to run a long dictionary, so this would be enough for us to start anyway. And of course, I'll choose a simple password for the SSH service to succeed the attack. But don't tell anybody else. The WC Linux command is used to count letters, words, and lines of a text file. The result means that Unix passwords file has 1,009 lines, 1,009 words, and 7,883 characters inside. Useful information. So let's continue to build the Hydra command. Hydra-L root-uppercase P password file Unix passwords.txt. F to exit as soon as finding a valid credential. -V is to show the login and password pairs of each attempt. Now that's used to increase the verbosity level. Target IP address, and finally the service to attack, SSH, and time to run the command. Okay, so I'll stop the attack by pressing the Control-C keys, but please look at the first lines. There's a warning here which says many SSH configurations limit the number of parallel tasks, and it recommends us to reduce the tasks using the T4 parameter value pair. Okay, I recall the command by pressing the up arrow and add T5 at the end and run the command again. Now it warns me that it will overwrite the restore file of the previous session if we do not abort the command in 10 seconds. The countdown starts. Now the attack started. So, as you see here, Hydra pauses the attack in every 5th try. Now we've got the results in seconds. We found the password of the root user of the SSH service running on the target system. Hydra says the password is password 1. Never seen that before. Now I have an SSH connection on the target system. Ha! Well done. John the Ripper is a fast password cracker currently available for many flavors of Unix, Windows, DOS, and OpenVMS. Initially developed for the Unix operating system, it now runs on 15 different platforms. It's one of the most popular password testing and breaking programs, as it combines a number of password crackers into one package, auto-detects password hash types, and includes a customizable cracker. John the Ripper is free and open source software distributed primarily in source code form. If you'd rather use a commercial product tailored for your specific operating system, please consider John the Ripper Pro, which is distributed primarily in the form of native packages for the target operating systems, and in general, it's meant to be easier to install and use while delivering optimal performance. Now, there is another version of John, which is the community-enhanced version. This version integrates lots of contributed patches, adding GPU support, OpenCL, and CUDA for 100 of additional hash and cipher types, including popular ones such as NTLM, RAW, MD5, etc., and even things such as encrypted OpenSSH private keys, zip, and RAR archives, PDF files, etc., as well as some optimizations and features. So let's see John the Ripper in action. Official free and open source version of John the Ripper is embedded in Kali. If you type John with no parameter, you'll see the manual page of the tool. You see the usage and all the options of John. Now let's build an offline dictionary attack with John. The first parameter is /word list. Don't forget to put the equal sign after the parameter. Name of the dictionary file with the full path comes here. So I'll open another terminal screen and search for a password list using the find command. Now there is a folder called word lists under the Metasploit framework folder. Let's go to that folder to see its content. Now there are a lot of word lists here for different purposes. Right now I want to look at the length of the password list file. Cat password.lst pipe WC for word count. The first one is the number of lines, and the second one is the number of words, which is the same with the line numbers, and the third one is the number of characters. So there are about 90,000 passwords in this list. I'll visit the file with less command. You can search a word inside the less command by pressing the / button. So I'll search for the password of the administrator. No result. MSF admin? No result. So note here that these steps are just to have successful results. In a typical penetration test, you won't know the passwords of the victim systems. Beyond that, if you already know the password of the victim, well, what's the reason of adding it to a dictionary and then finding it again? Suppose that these steps never happened and the words were already in the list we used, right? Now I'll open the dictionary and add a few words. So I'll repeat that we're just supposing that the process never happened and the words were already in the list, but I just wanted to show you the mechanics of it. So now we can use this list as the word list in John. So write the file name with the full path. The second parameter is the hash file. Now I'll run the command adding no more parameters first. So if you don't specify the hash type, John detects itself. It detected the hash type as LM and warns us about the NT hash. And here are the results. Guest password is empty. It also shows the first part of the administrator's hash and the second part of CyberLab's hash. And as you see here, in all uppercase letters. Now I'll recall the latest command and add the format parameter as NT this time and hit enter. Here are the results. Now we see all the letters in their own formats, uppercase or lowercase. So now I want to try to crack the Windows 8 hashes. So I'll give the hash file of the Windows 8 system this time. I remove the format parameter and run the command. John reckons the hashes as LM and got no result. So let's give the hash format. Now we have a result. Password of a Udemy user is Udemy 12. But wait a second. Windows 8 has a user with the password 1234QQQ uppercase Q and dot, which is the same with the password of the administrator user of Windows XP. We know that the word is in the dictionary, so why couldn't John crack it? Well, the answer is inside the john.pot file. So let's find its location using the find Linux command. And let's see the content of the file with the cat command. So John stores the findings in john.pot file with a hash format. And if it finds the same hash with the same format, it doesn't try to crack it again. So you should look at the john.pot file for the hashes you try to crack with John, right? So if we run the latest command again, it won't crack any hash because they've all been cracked before. So if you delete the john.pot file and run the latest command again, you'll see all the cracked results of the hash file. Good, so let's move on and try to crack the hashes of the Metasploitable Linux VM now. The hash file is #m2.txt, and don't give the format parameter. I'll let John detect the hash type, and hit enter. So it detected the hash type as MD5 crypt, and that's correct. So look at that. We cracked passwords. The passwords of the Metasploitable users are not so complicated, are they? So look at the john.pot file once more. And now you see the new hashes stored with hash type 1, where 1 stands for MD5. Excellent. All right, so Hashcat is a type of hacking tool and a password cracker specifically.
It was created to be able to hack the most complex of passwords, targeting multiple aspects of coding simultaneously. What's the secret sauce of Hashcat? Well, it's going to crack passwords by using your graphics card on your computer. So let's try it out. All right, so for right now, we are going to crack an MD5 hash that has been created before. You can see the hash that we will crack saved in a text file. Now, Hashcat comes installed by default on Kali Linux, so just open up the terminal, write sudo sudo dash, and you can just type hashcat --help, and that is going to bring up all the options that you're going to need to know in order to run properly. All right, so the first option that you need to specify is -m. So this option determines a hash type, and the hash type is going to be a number, and the numbers will represent hash types are shown below. So here are the options to use Hashcat. You'll need to select your attack mode and hash type. Right, so the next option is the attack mode. So if you go down here, you can see the attack mode types, and I'll use a dictionary attack or straight mode, which is a very simple attack mode. You might also know it as a word list attack. Now, if we look at a few of the other modes here, combiner attack. Now, this is the addition of each word of a dictionary to each word in the dictionary. Brute force tries all combinations from a given key space. And the hybrid attack is just a combinator attack. So one side is simply a dictionary, the other is the result of a brute force attack. So in other words, a full brute force key space is either appended or pre-appended to each of the words from the dictionary. That's why it's called a hybrid. All right, so we're going to write a simple command. Just write hashcat -m0. So I'm going to choose 0 because the hash that we will crack is MD5. -a0 to select attack mode and specify the hash path that we will crack, which is hashes.txt. And the word list that we use, I'm going to use the Wscube word list, but you can use another word list as well if you want. So I'll open up a new terminal and write locate word lists. So you can see the word lists that are usable on Kali. If the hash is more complicated, you can choose a bigger word list. But anyway, let's get back to the example. So in the final part of this, I'll write --show to see the result. So here is the result, and the hash, and the result of the hash. All right? Now, I do need to tell you that the attack mode or hash type will vary from problem to problem. So you do need to choose options suitable for the problem that you face. The Hashcat also has a few different features. You can use a word list with rules. Hashcat rules are rules that are programmed to accommodate the rules engine in Hashcat. So hash rules are efficient because they can produce complex patterns of words from our target word lists. But it's by using rules we can attempt some more complex passphrases, allowing us to crack more passwords from our target hash table. So for use rules, we can use the -r option, retype the command that we just typed without the --show. So write -r and the path of the rule, which is /user/share/hashcat/roles. You say that 3 times fast. Now, if you press tab, you can see all the rules. So I'm going to select base64.rule, and in the final part, just write --show to see the result. And here's the result. All right, so that's Hashcat and how to use it.
Hashcat. Today we are going to learn how to crack hashes with the Metasploit introduction and solutions on the TryHackMe platform. In the Crack the Hash room on TryHackMe, we encounter the following questions with some hints provided.
These hints help us identify the algorithm used to encrypt our hashes. Our tool of choice for this task will be Hashcat. For our first question, we notice that MD5 was used. We attempt to crack the hash using Hashcat with the MD5 algorithm. And as we can see, the password is easy. Next, we are presented with a hash encrypted using the SHA algorithm, but we are unsure of the version. It appears to be a short hash, so it is likely encrypted using SHA 224. Again, we use Hashcat to crack the hash, and we discover that the password is password123. Moving on, we have another hash encrypted with the SHA algorithm. This time, it is considerably longer, so we presume it is SHA 256. We proceed to use Hashcat to crack the hash. And the password is revealed to be let mean. For the next solution, I'll demonstrate a different approach. I create a file named hash.txt on my desktop. After determining that the algorithm used is Blowfish with hashcat mode 3200, I decide to optimize the process by reducing the complexity of the word list. Since it's mentioned that using the rocku.txt word list might be time-consuming, I reduce it to 4 characters. As a result, I create a new text file on my desktop containing 4-character words. However, when attempting to save the hash to a file, I encounter an error. After troubleshooting and using the show command, I find out that the password is belay. Next, I have a hash that is indicated to be encrypted with the MD4 algorithm. Despite trying to crack it using mode 900 and hashcat, I encounter an error. Instead, I demonstrate that we can also crack hashes online using websites like hashes.com. As seen, the password for this hash is eternity22. In summary, we first identify the hash algorithm, determine the hashcat mode, and then proceed with the cracking process. Hashcat provides a powerful and versatile toolset for cracking hashes, allowing us to efficiently crack passwords and gain access to secured systems.
Developed by Edge Security, the Harvester is a command-line program written in Python, which is to gather emails, subdomains, hosts, employee names, open ports, and banners from different public sources like search engines, PGP keys, and Shodan computer databases. You can download the Harvester from its GitHub page, https://github.com/Laramies, that's LARAMIES/the Harvester. It's also embedded in Kali Linux. When you run the script with no parameters, you can see the usage options. One of the usages of the Harvester tool is the harvester-d domain name -l result limit -b data source. When the script finishes its job, you can see the results: emails and hosts found. ReconNG is a full-featured web reconnaissance framework written in Python, complete with independent modules, database interaction, built-in convenience functions, interactive help, and command completion. ReconNG provides a powerful environment. ReconNG has a look and feel similar to the Metasploit framework, reducing the learning curve for leveraging the framework. ReconNG is designed exclusively for web-based open-source reconnaissance. If you want to exploit, you can use the Metasploit framework or any other exploitation tool. You can download the Recon framework on the website seen on this slide. And it's already embedded and ready to use in Kali Linux. When you run ReconNG script, you'll end up with a shell-like interface. Now you can use ReconNG commands. Type help to see the available commands. You can use search commands to find the modules we need. For example, we can type search XSS to find the module which is aimed to find out XSS vulnerabilities. Type use keyword with the module name to use the module. In this example, let's use recon/domains-vulnerabilities/XSSED module. This module checks xssed.com website for XSS records associated with the domain. Set the source parameter value. Type run to run the module. In this example, we found an XSS vulnerability for nhs.uk website was published in 2008. Even though we're almost sure it was fixed years ago, it's better to look and see if the vulnerability still exists. Maltego is an interactive data mining tool that renders directed graphs for link analysis. The tool is used in online investigations for finding relationships between pieces of information from various sources located on the internet. The focus of Maltego is analyzing real-world relationships between information that is publicly accessible on the internet. This includes footprinting internet infrastructure as well as gathering information about the people and organizations who own it. Maltego can be used to determine the relationships between the following entities: people, names, email addresses, and aliases; groups of people, social networks; companies; organizations; websites; internet infrastructure such as domains, DN names, net blocks, and IP addresses; affiliations; documents and files. Connections between these pieces of information are found using open source intelligence, OSINT techniques, by querying sources such as DNS records, Whois records, search engines, social networks, various online APIs, and extracting metadata. Maltego provides the results in a wide range of graphical layouts that allow for clustering of information, which makes seeing relationships instant and accurate. This makes it possible to see hidden connections even if they're 3 or 4 degrees of separation apart. You can download the Maltego CE, that's the Community Edition, from www.paterva.com, and it's embedded in Kali Linux. Let's see Maltego in action. Go to Kali Linux and open a terminal screen and type Maltegos, that's Maltegoce, to run Maltego Community Edition embedded.
And naturally, there are different types of Maltego editions. So we'll choose the Maltego Community Edition. Why? Because it's free. All right, so first we'll need a login. Now, if you don't have an account, you can just click here to register. If it does fail to execute in the default web browser, just open up your browser and go to Register Website. That you can see here on the screen. And create an account, log in. Cool. So here is a summary of the progress to install the different items. You can always choose to send your error reports to improve Maltego. And we'll choose the web browser for Maltego. And yeah, now you can see it's ready to start. However, here, let's choose the privacy mode. So we need to create a new graph before scanning a domain. Cool. Click on the Maltego icon on the top left up here. Click New.
The second step is to specify the target domain.
And when we choose all transforms and click to run, it's going to start to collect data. Far out.
Now, in the Community Edition of Maltego, the results are limited to 12 entries. It shows the results in graph mode. We can zoom out to see the entire picture or zoom in to focus on specific results. Now, if you select a node and right-click on it, you can see all the transforms you're able to run for that node. Transforms are grouped according to their purposes. You can expand a group and select a single transform to run, or you can run a group of transforms at once. You can configure a transform before the run or save a transform in your favorites list. Let's run the mirror:\email addresses found transform at this time. The results start to come in about a minute. Let's see some more about Maltego while we're waiting. There are different graph types you can choose to see the results. If you zoom out the graph under 30%, The entities are shown as the dots instead of meaningful symbols. All the colors of the dot point to a specific type: email addresses, websites, domain names, and more. You can see the color legend in the lower right corner. The results of the transform we ran a minute ago are here now. You can use the toggle full screen button or simply press Alt plus Enter buttons to toggle the graph to full screen. You can select the email addresses node and see the collected email addresses listed in the detail view window.
Great. So in this lesson, we're going to learn how to perform DNS enumeration with the DNS enum and DNS recon tools. So first of all, of course, what is DNS enumeration? In fact, what is DNS? Good question, so I'll answer them. So DNS, the domain name system, works at the application layer level of the OSI model. DNS is a system, and it's used to convert a computer's host name into an IP address on the internet. For example, if a computer needs to communicate with the web server hackeracademy.uk, your computer needs the IP address of the web server hackeracademy.uk. It is the job of the DNS to convert the host name to the IP address of the web server. DNS uses both UDP and TCP. Now, of course, if you need more information about this, you can just visit our DNS lesson in Section 2. So DNS enumeration, it's one of the most popular discovery tasks available to create a profile of your target. It's the act of detecting and enumerating all possible DNS records from a particular domain name. This includes host names, DNS record names, DNS record types, TTLs, IP addresses, and a little bit more, depending upon how much information that you're looking for. So after DNS enumeration is complete, unauthenticated users can then use this information to observe internal network records and obtain useful DNS information that allows the attacker to access a complete DNS map. Now, of course, there are many tools that can do DNS enumeration. We're going to first look at DNS enum and DNS recon. So first up, DNS enum is a command line utility that detects basic DNS entries such as MX, mail exchange servers, NS, domain name servers, and A, the domain's address record. Now, it also attempts zone transfers on all identified servers and performs reverse resolution and brute force attacks on subdomains and host names. Secondly, DNS recon provides users the ability to execute a wide range of tasks, from security audits to basic network troubleshooting. It provides many features like DNS enum. So you can check DNS server cache records, enumerate general DNS records for a given domain, check all NS records for zone transfers, check for wildcard resolution, and it checks the brute force subdomain. So let's try some of these tools out. Open Terminal. So let's start with DNS enum. In this test, we're going to use zonetransfer.me for DNS enumeration because this website is developed specifically for getting experience about security problems related to DNS zone transfer. All right, so just write man DNS enum. And here you can see the description of DNS enum, options for DNS enum, and the usage of DNS enum. So I'm going to do a simple scan. So I'll write DNS enum zonetransfer.me. And there you see the scan starts. And of course, it'll take some time because it's a pretty large scan. So here are the results: the server names, mail servers, trying zone transfer, getting bind versions, brute force to find domains, reverse lookups on net ranges, as well as the results. All right, so secondly, we've got DNS Recon. So write man DNS Recon. You can see the description of DNS Recon, options, and usage of DNS Recon. And again, I'm going to do a simple scan, so I'll write DNS Recon and the target IP address, which is zonetransfer.me. Okay, good. So what you're looking at are the server names and mail servers, as well as all kinds of stuff. So you can actually specify your scan and look for more deeper results. All right, so that is DNS enumeration, as well as how to use DNS enum and DNS Recon. Now, another great discovery tool, including Kali Linux 2021.2, is NetDiscover. Now, this is a tool that can perform Layer 2 discovery. NetDiscover is a simple ARP scanner. All right, so you can use it to search a network for live hosts. It can also search for multiple subnets. Now, when you're trying to access a network, you can utilize this tool in the early stages of a pen test. So it has many different features like simple ARP scan, and it works in both active and passive modes, produces a live display of identified hosts, and is able to scan multiple subnets, timing options, and all sorts of things. So we're going to see NetDiscover in action. So first, let's have a look at the manual of the NetDiscover tool. Type man NetDiscover and press enter. So here's the full definition of the NetDiscover tool, and you can read it completely all on your own. I just want to show you a couple of the options and the descriptions of them. So right now we are going to use the -R option to specify the network range. So first we'll have a look at the network address before scanning. So I'll open up terminal, write ifconfig, and here's our IP address. So now we know which IP range that we're going to look at. So let's scan the network. Write sudo su for root permission, netdiscover-r parameter for scanning a given range instead of auto scan, and the IP address. We can specify the range like writing /16 to the end of the IP address, right? So press enter. So it's going to search the network range for live hosts, and it may take some time. All right, so we've got the result of the live hosts. So now we have learned what NetDiscover is and how to use it, and we will be. All right, my friends, welcome back. So we're going to start with Whois. So this Whois lookup, it's an internet protocol used to query details associated with a domain name, such as the domain name's owner, registration date, last update date, DNS, the domain name system records, as well as other related information. Now, the Whois information is actually provided by a specific registrar responsible for managing domain name registrations, and it's typically publicly available. The Whois lookup is performed either through online tools or Whois queries in order to obtain that basic information associated with the domain name. So this information usually includes who the domain name is registered to, when it was registered, when it was last updated, and when it's going to expire. Additionally, technical details such as contact information for the owner and the domain name's DNS configuration may also be available. So this Whois lookup can be used to verify domain name ownership, as well as communicate with a domain name owner or learn technical details related to the domain name. For example, if an individual or organization wishes to purchase or transfer a domain name, they can use the Whois information to contact the current owner of the domain name. So now let's get into some examples about this whois lookup for a few web pages and see where we go from there. Now, in order to be able to perform these examples, first, just open up the Kali Linux. And after opening Kali Linux, the first thing that we're going to do is open our browser. All right, so just by typing whois, we can see the available sites, but I will access this site in particular. Right, so after we enter, just type in the name of the site whose information we want to learn. For example, I'm typing in SAHIBINDEN.com. And now we want to learn whatever we can find. So, as you can see, it shows me all kinds of information about SAHIBINDEN.com, including potentially useful information such as the attack surface. The name of the site's administrator appears to be hidden. Some email addresses, though, are provided. So what do you suppose we're going to do with these email addresses? Now, we could potentially use these email addresses for phishing attacks or social engineering attacks in the future. Now, as you can also see, the email addresses provided here don't seem to be very realistic. Interesting. This means that the site owners have put some protections in place, wouldn't you think? Now, similarly, server names such as DNS01, DNS02, DNS03, those are also visible. We can also see some information about the expiration date of the site's name rights, registry date, update date. All right, so that's what we get with a whois query. But you see this here? There's a DNS records button. So when you click on it, we can see that our site's IP address, IPv6 address, or cloud name is right there visible. And similarly, when we click on the diagnostic section, it's going to ask me to confirm that I'm a human. Well, I always get conflicted about that because I wonder, am I a human? But we'll put that in a different video because for now, yeah, I'll just pretend. So in this section, by running the ping command on the site that we want to obtain information about, it's going to show us the output of the command. And we see the outputs here. And we can also use the traceroute command. We can see the different routes and the hops that our pings have to go through to get to the website and where each one of them are located. All right. But guess what? We can already use the whois query that comes within Kali Linux. So when we just type in SAHIBINDEN.com, it gives me all kinds of information, like the domain name and the domain ID. Actually, if you have a look, we actually see a very similar output to what we saw earlier. But see, the reason why we work in here is we're able to access this information a lot more quickly. So, what should we generally pay attention to? What information might actually be important to us? Well, in general, we can look for, like I was saying earlier, email addresses related to a site, and that could be usable or even necessary for social engineering attacks. But as you can see, the email address here does not seem, well, it just seems like it's a fake one, right? Now, similarly, we can see that the name of the site owner is here, and we can access this kind of information. Now, with another example, I want to show you some of the results of the Whois query that I performed for another site. And you can see here the site's owner's taken some measures to protect themselves as well. We can see some email information, but yeah. These email addresses don't seem like they're gonna work, right? So don't give up, don't despair. This just means that they've taken a few measures to guard against attacks. Now, we can also derive here that this website uses cloud technology. All right, so there you go. Whois query, passively gathering information, because we're still at the information gathering page. Don't expect the entire world to open up to you. All right, see you next time. All right, my friends, welcome back. So we have to first define what is web pen testing. Now, you also might know it as web application penetration testing, but it's basically a systematic process of evaluating the security of web applications by identifying and exploiting any vulnerabilities. So we're aiming to uncover potential weaknesses that malicious actors could exploit to compromise the confidentiality, integrity, or availability of the application and any of its data. All right, so now let's have a look at the key components of web pen testing, which are understanding web applications, attack surface analysis, threat modeling, testing methodologies, and stages of web pen testing. So now let's have a look at each of these one at a time. First up, understanding web applications. So web pen testers need a deeper understanding of how web applications function, including the technologies, frameworks, and protocols that they use. This understanding helps identify potential entry points such as input fields, authentication mechanisms, as well as data processing functions. Which brings us to attack surface analysis. So pen testers analyze the attack surface of web applications to identify all entry points accessible to potential attackers. So this includes examining the application's endpoints, APIs, authentication mechanisms, as well as data storage systems. Then third up, we've got threat modeling. Pen testers conduct threat modeling exercises to anticipate potential threats and prioritize security testing efforts. And by identifying likely attack scenarios and their potential impact, pen testers can tailor their testing strategies to focus on the most critical areas. Then we've got testing methodologies. Yeah, because web pen testing employs a variety of testing methodologies, including what they call black box testing or white box testing. There's even gray box testing. But black box testing basically simulates attacks from an external perspective, while white box testing involves analyzing the application's internal code and architecture. Gray box testing combines the elements of both. All right, so now we're ready to have a look at these stages of web pen testing. Target identification and information gathering. So pen testers identify the target web application and then gather information about its architecture, the technologies that are used, as well as potential vulnerabilities. This stage may involve reconnaissance techniques like footprinting, DNS enumeration, and web crawling. vulnerability scanning and analysis. So pen testers can use automated scanning tools, as well as manual testing techniques to identify commonly known vulnerabilities such as SQL injection, cross-site scripting, better known as XSS, insecure authentication mechanisms, and insecure direct object references, or IDOR. Vulnerability scanners help to identify known vulnerabilities, while manual analysis uncovers complex or unique issues that automated tools might actually miss. So once vulnerabilities are identified, pen testers attempt to exploit them to gain unauthorized access or escalate privileges within that application. This may involve crafting malicious payloads, exploiting misconfigurations, or even bypassing security controls to achieve their objectives. Pen testers will document their findings in a comprehensive report detailing discovered vulnerabilities, their potential impact, as well as their recommended remediation steps. So the report is shared with a development team or system administrators that are responsible for addressing the identified issues. The remediation efforts aim to patch or mitigate vulnerabilities, improve security controls, as well as strengthen the overall security posture of that particular web application. Well, now that you know about the importance of web pen testing and its importance, we'll wrap it up here, and then when we come back in the next videos, we'll see some web pen testing tools, as well as what the heck is bug bounty, as well as some popular bug bounty sites. All right, so I'll see you next video. And we're back. We're going to explore the various tabs within Burp Suite and also understand their functionalities. But first, we'll cover the basics. So we're going to delve into the fundamental basics of Burp Suite. We'll cover the installation on different platforms, basic configuration settings, initial setup. Once you understand these basics, well, you're going to have a very smooth experience with Burp Suite throughout the rest of the course. First up is a dashboard. You see the dashboard tab serves as a central hub for monitoring and managing your testing activities. Now here you can actually view in real time updates on intercepted requests, responses, as well as any security issues detected during your testing session. Additionally, you might want to customize the layout and the widgets to suit your preferences and workflow. And as you can see, the dashboard is structured quite well. And here we can see the sites that we visited, requests we've made, different tasks we've done, configurations, other developments. And here's our log section, right? So it's all here in the dashboard. Let's move on over to the Target tab. So this Target tab is where you define and manage the scope of your testing. You can add target applications, specify inclusion and exclusion criteria, as well as configure various settings to tailor your testing environment. So understanding the Target tab is perhaps obvious, but it is essential for effective targeting and scoping of your security assessments. So in our Target section, we have our sitemap under the Target tab, along with the scope and the issue definition sections. And since I've previously added this site to the scope section using the Add button, it's only this site added subdirectories that you can see here in my sitemap section. Moving on to the Proxy tab. So here under the Proxy tab is hiding, but certainly not dormant, a core component of Burp Suite, allowing you to intercept and manipulate HTTP and HTTPS traffic between your browser and the target application. Here you can set up your interception rules, modify requests and responses on the fly, as well as analyze traffic patterns for potential security vulnerabilities. Additionally, configure SSL settings for handling encrypted traffic transparently. All right, so moving on after the Target section, move into the Proxy section.
You see, this part can be considered actually the most frequently used area because here's where we perform packet captures. So we turn on intercept, we enable packet interception, and this allows us to mediate packet flows. Now, conversely, when intercept is off, we actually permit packets to pass through without any interception. So we'll just illustrate here with a simple example. So imagine that we have a website and I navigate to the My Account section. So after turning on intercept, when I click Login, as you can see, we capture packet and its content. Now, back in the proxy section here, there are other functionalities available as well. We can observe the methods used to make requests to the visited sites, which URLs were accessed, and so on and so forth. You get the idea. Now, similarly, we can configure WebSocket and proxy settings. And here we can specify which ports and IP addresses Burp Suite should use to differentiate its operations. All right, so let's make some more progress here and go to the Intruder tab. Now, here's where we transition from manual testing to automated attacks. This is a very powerful tool. It enables you to launch customizable attacks against target parameters like usernames, passwords, and input fields using various attack payloads as well as different attack types. You can analyze the responses to identify potential injection points and security vulnerabilities very efficiently right from here. Now, additionally, we can modify our attack patterns and conduct attacks on different targets by changing our attack methods. And we can specify where to inject variables or payloads. All right, so far so good, right? But there's more. What's under the Repeater tab? Well, this provides a sandbox environment for manual testing as well as some experimentation. So here you can resend and modify individual requests in order to observe their impact on the target application in real time. Now you've got full control over request parameters and can analyze server responses to understand application behavior, as well as identify potential security flaws. Check this out. With a Sequencer tab, we actually shift our focus to analyzing the randomness and predictability of tokens and session identifiers used within the target application. So by capturing and analyzing sample data, you can perform statistical analysis to assess the strength of cryptographic algorithms and identify potential weaknesses in session management mechanisms. All right, let's check out the Decoder tab, because this is going to offer a suite of tools for encoding and decoding data in various formats commonly encountered during web security testing. So here you can decode URL-encoded strings, base64 encoded data, as well as other encode formats, as well as encode data for payload manipulation and evasion techniques. We'll get to all that soon. But I want to also point out that you can perform hash computations as well as cryptographic operations for data validation and integrity checks. There's even more, though. In the Comparer tab, you can compare two HTTP and HTTPS requests or responses side by side to identify differences, similarities, anomalies. This feature is actually very useful for identifying variations in server responses, also detecting changes in application behavior, and pinpointing security-related issues such as inconsistent input validation or output encoding. Now the Logger tab. So this records all HTTP and HTTPS traffic exchanged between Burp Suite and the target application,
providing a comprehensive log of requests, responses, as well as all the associated metadata. You can review logged entries, search for specific requests or responses, and filter traffic based on various criteria. Additionally, you can export logs for further analysis or documentation purposes. Let's see what the extender tab's for. Yeah, so this serves as a platform for extending the functionality of Burp Suite through custom plugins, scripts, and integrations. So you can install and manage existing extensions from the BAP store or even develop your own using Burp Extender APIs. So this extensibility is outrageous, right? I mean, it actually allows you to enhance your testing capabilities, automate repetitive tasks, and integrate Burp Suite with other security tools and frameworks seamlessly. That's why you want to get to be an expert, so that you can come in here and write some extensibility. All right. Now that we've completed the walkthrough of the Burp Suite Basics room and the Try Hack Me platform, let's go ahead and solve the Burp Suite room on Try Hack Me. A personal proxy gives you a direct view into how your target application works under the hood. It operates as a web proxy server and sits as a man in the middle between your browser and destination web servers. This lets you intercept, inspect, and modify the raw traffic passing in both directions. If the application employs HTTPS, the personal proxy tool breaks the SSL connection between your browser and the server, so that even encrypted data can be viewed and modified within the proxy. So here's a demo. Setting up the personal proxy and your browser to work with each other involves the following elements. First, we need a proxy listener to accept requests from your browser. We can use Burp Suite for this purpose, which is embedded into Kali Linux. By default, Burp Listener uses port 8080. Second, we need to configure our browser to use the proxy listener as its proxy server. We can change the proxy settings of our browsers from the following menus: Preferences, Advanced, Network, Settings. Or even simpler, we can use plugins such as Foxy Proxy to change the proxy settings with a single click. When you install the plugin, a Fox icon appears next to the address bar. Since Burp Suite Listener listens to the port 8080, we redirect the traffic to that port. Now, let's see how we intercept the traffic and modify the requests. Go back to Firefox. Foxy Proxy is disabled at the moment. Visit http://nhs.uk or whatever you want. Now, open the Burp Suite. In Burp Suite, make sure that the intercept mode is on. Go to Intercept tab under the Proxy tab and see the Intercept button is on. So back to the browser and select the personal proxy for port 8080 from the Foxy Proxy plugin. Type green, or whatever you want, into the search box in the upper right-hand corner and press enter. The response is caught by Burp Suite. Find the word we search for in the request, change it, for example, yellow, press the forward button. Now there will be following requests for the resources of the website which we are not interested in, so we can turn the intercept off at this point to avoid time loss. Go back to the browser, and as you see, we sent green to search, but since we changed it using a personal proxy, we have a different result now. If you try any website which uses HTTPS protocol, such as google.com, you probably got the message that your connection is not secure. To be able to intercept the traffic, Burp Suite handshakes with the website, and we handshake with Burp Suite. Since we haven't added the Burp Suite certificate as trusted, you get that message. Go to Advanced and add exception. Then you can keep going. Burp Suite makes the handshake with the website, and we make the handshake with Burp Suite.
Let's see the best way to intercept HTTPS traffics using Burp. The safest way to intercept HTTPS traffics is to install the PortSwigger certificate on your browser. PortSwigger is the owner of the Burp Suite tool. First, let's delete if we have any previously installed PortSwigger certificates. If you didn't try to install a PortSwigger certificate before, you can ignore this step. Open Firefox. Now, from the menu button at the upper right side of Firefox, follow the path to open the certificates list. Preferences, Advanced from left, Certificates, and click View Certificates button. Look at the first if there is any PortSwigger certificate and delete it if there is. Now it's time to run Burp Suite. Configure the browser to use Burp. For this purpose, from the Foxy Proxy icon, I choose location host 8080, which is designed to listen to port 8080 of the local machine. Type http://burp/ in the address bar of Firefox. Click CA certificate, link at the upper right-hand corner, and save the file. It's now saved in the download folder on my computer. Now let's import the download certificate. Again, from the Firefox menu, follow the path to reach the certificate page. Preferences, Advanced, Certificates, and click the Import button. Choose the certificate you downloaded a few seconds ago. Check Trust this CA to identify websites, at least, and click OK. Now it's time to intercept an HTTPS traffic. I'll intercept the traffic of google.co.uk page. Go to the Burp Suite. As you see, the intercept is on and the request is caught by the Burp Suite. To test if everything is okay, I'm going to search for a word, intercept the traffic, and change the word with another one. I write OWASP in search bar and hit enter. Burp caught the request. I replace the word OWASP with CI security and turn the intercept off to allow the traffic flow. When I go back to Firefox, I see that the word CI security has been searched instead of OWASP. It works like a charm. Social Engineering Toolkit, SET. The Social Engineering Toolkit, SET, was created by Trusted SEC. It is an open-source Python-driven, specifically designed tool to perform advanced attacks against the human element. It's a standard tool in a penetration tester's arsenal. The attacks built into the toolkit are designed to be targeted and focused attacks against a person or organization used during a pen test or ethical hacking. You can download SET from Trusted SEC's GitHub and use any platform you want, and it's already embedded in Kali and ready to use. The tree on the slide shows the attack types under the Social Engineering Attacks branch of the main menu SET. And the green layer shows the methods of website attack vector options. I mean, there are many more methods and attack vectors in the toolkit. Let's see one of the attack methods of the Social Engineering Toolkit, Credential Harvester Attack. In this attack, first we should choose a website which has a login sequence that the victims often visit. The toolkit prepares the clone of that website and serves it at the server. Our trap is ready and starts to collect the inputs of the victims. When a victim visits our website, he or she will face exactly the same page that he or she visits often. The victim enters the credentials and we collect them. Let's do it together. Social Engineering Toolkit is installed and ready to use in Kali. It's defined in the path so you can start the toolkit anywhere using Set Toolkit command. Choose Social Engineering Attacks option in the main menu, that's number 1. As the attacked vector, select Website Attack Vectors, that's number 2. And our attack method is the Credentialed Harvester, number 3. This menu is the list of the phishing website creation methods. Let's choose Site Cloner, number 2. We need to have a website where the victims visit and log in often. I want to find a login page for the NHS. Googling for NHS and login keywords, email.nhs.net seems good. Postback IP address is used for what IP the server will post to. Now this is the URL to clone. I use email.nhs.net. The version of the toolkit I use is 7.6.1, and when I want to clone a website, I get a zip importer error and the method does not continue. When I Google the error message, I found a solution for this problem in the Issues section of the GitHub page on the Social Engineering Toolkit. Go to /etc/ctoolkit/set.config file. In line 95, turn off to on. And save the file before closing. Now run the SE Toolkit again. Follow the menus again, 1, 2, 3, 2. Enter the IP address of our Kali machine as postback IP address. Enter email.nhs.net as the URL to clone. The same error message is here again, but now the program continues and asks for starting Apache server if it's not running at the moment. Answer Y for yes, and the trap is ready. The site's cloned, Apache server started, and the credential harvester is listening to the inputs now. As the victim, when we visit the malicious website, we will see exactly the same page with email.nhs.net. Enter the username and password, click Sign In. Our malicious website redirected the victim to the original page, email.nhs.net. It's a good idea. The victim will not be in any doubt about the fraud. Turn back to the attacker system, Kali, and you'll see the credentialed information entered by the victim. You can leave this command window. Everything is still running and logging under your web directory path /var/www/html. To make the credential harvester attack more realistic, you can use some tricks. For example, you can use the domain name of the target company as a subdomain name of your registered domain name. Suppose that you're the owners of xyz.com domain, and the domain name of the target company is thecompany.com. You can prepare a URL like thecompany.xyz.com. Another way to make the attack more realistic is to buy a domain name similar to the domain of the company. For example, if the target domain is thecompany.com, you can try to buy the company with a double N. You can also use the URL Crazy tool to find out the alternative website names. If you're an insider, you can try to match the domain name with your IP address to redirect the victims to your servers using DNS spoofing.